YouTube and hit refresh on that. And let's just grab that second chat. Literally nobody saw my dance party at the beginning. That's pretty funny. All right, open up my own YouTube video because I'm vain. And then let's pop out that chat. Pop out. I'm like looking around the camera and my neck's getting stiff. I had a terrible sleep last night. Absolutely awful. I don't know what, there was a thunderstorm that came through, which should by all means be calming, but when you get woken up by the sound of a washing machine being dropped from a fucking airplane every now and then, it gets a little tedious, especially when you have precious sleep time and your schedule is starting to change. I'm starting to sleep earlier and earlier, so I'm trying to actually actively change my schedule so that I'm up at the normal hours that human beings exist. But then towards the morning, when I finally was able to get some sleep, the thunderstorm kind of rolled through a little bit, finally able to get a little bit of sleep, and then my insulin pump runs out of insulin. And so I get woken up with the mystery noise that I'm not quite used to yet. Oh, I gotta roll all the way downstairs, get another pod, fill that up with insulin, you know, poke the phone until that becomes a reality. And then I could go back to sleep, but only for a little bit, because then I need to walk the dog early in the morning, because otherwise she doesn't have anywhere to go to the bathroom. So it's not so much that I'm being kind, it's that she has me under duress in order to force me to let her go to the bathroom in the morning. The dog is calling the shots. So yeah, it's like, I better get her outside. So I had to then get all my shit together and wake up. I know, I'm complaining about being like a normal person, right? This is not... If I'm complaining about this, what is my life like? Oh boy. Let's get all this module stuff away and out of the way. Way out of the way. It's so funny to have Julian kind of go over my synthesizer, the stuff that I have in my modular setup, compared to like what he has in his, and it was like things were confusing to him, which I found fascinating. What is this? Some of these boards that are sitting up in this heatsink that I have, I do not know what they do. Wow, that is a what is going on with that camera? Woo! Okay, hold on. We got to prime this camera. Apparently it fell out of priming. So this one would be the microscope properties. Figure Vito. Let's put these back into place. That's right, some of my cameras fall out of calibration, so I need to get them back. Let me do that for a minute. Still monitoring chat, nobody's around. Everybody busy today. Jeez. So do that. Some of these, oh, it looks like it remembered the settings. Why is it all blown out? Oh, because the contrast went crazy. What does a motion look like on it? That's pretty good. I can't hate on that. All right, let's take this to -5. Maybe I hit the controls for it or something. That gain went all crazy too. That was a bit of a problem. And we can bring this back in, and then that looks pretty good. It's a filthy breadboard sitting underneath this thing, so. All right, so what was this chip? What is this thing that I have? SDA, SCL, 2 grounds, and out. Oh, is this an accelerometer board? Yeah, MCP 4725. I think this is an accelerometer board. That was meant for the 3D printer. Cute little accelerometer, if that's what it is. There's a little 6-pin jobby. Neato. Current monitoring. I wonder if I should be doing any current monitoring on my device, on my module tester module. That'd probably be a good idea, just to see what the draw of the module is. So like right before the power plugs, I'll put a current shunt. And I think I have a shunt amplifier somewhere. I think I have one in my bins. Either that or in drone stuff, I'll definitely have one. Let's get what we need from here. We need knobs, maybe. We might actually not need knobs. Let me put knobs aside. I'll put knobs over here for now. We will need our plugs though, so we'll take plugs away from the filter. Bring that over here.
little dear, our dual output from the, we're going to do the ADC, the DAC. We're going to do the LBC. Yeah, you know me. No, we're going to do the DAC, the output from everything. Try to get that up and running. That's not a very complicated task. That's not a super complicated task. So we should be pretty successful in that. I can get my notebook out of here since the notebook is for Dave's module, not for any of this stuff. I have been working on the POS CNC. I did a couple of cuts of that frame rail. I kind of messed up the cut though. I cut it sort of on opposing sides, and so my sides don't match anymore, because these are all parts from what was going to be Burn the Subs. You know, we were going to do massive upgrades to Burn the Subs. I decided to make it a little faster by doing small upgrades to Burn the Subs, and then I got bogged down in doing the upgrades to Burn the Subs, and that languished and is kind of shelved. I got to get back to it, but this module stuff, I need to complete some of these projects, and in order to do that, I need to start up another project. Classic yak shaving. But once I get a module testing module, I will then be able to put the 303 down and give it the stuff that it needs to function. I don't have a way to give something like a gate signal in order to test its functionality, and that keeps biting me in the ass. I keep giving stuff to these guys back and saying it's fixed, and then they'll test it and be like, nah, it doesn't work. So I need less EE like ways. I need to test it like it's a module, and I'll know that it works when my module tester says it does. So that's what we're working on now. That's why we're concentrating on this. I'll do a lot of work in the background to try to make this one a little bit less painless, but this one is going to be a classic, like very difficult to follow through project because it's a big thing. Building an entire device, not easy, and a piece of test equipment that's going to help me going forward. That's also equally really, really difficult to do. So we got our job lined up. We got our work cut out for us. That's what I meant to say. But given all the tools that we have at our disposal, we should be able to get this thing together pretty nicely. Now, this was the oscilloscope testing stand. I got some parts in today for the O-scope test, and I have a lot of coding to do for that. So I'm taking it apart. I'm breaking this one down. The O-scope screens, the oscilloscope modular synthesizer module based on Hajiwo, those are going to be circular yellow LED screens. It's going to be pretty cool. Hear you on that. I had to finish a CNC router project so that I could cut out some parts for a 3D printer project so that I could do an RC project. That sounds exactly like that. That almost sounds exactly like what I'm doing right now. Except the RC car part is exactly why I'm building the POS CNC. The POS CNC is because I was going to, again, massively upgrade Burn the Subs, but I didn't follow through with that and have a $1,000 servo controller and some massive outrunner motors. These are the kinds of outrunner motors that you would put on a skateboard in order to propel yourself forward. I don't know why I bought them so big, but it turns out you can turn those into NEMA 27 equivalents. So I have this DeWalt router from the brewing table and these, the massively expensive controller, as well as leftover rails from Burn the Sub potential upgrades that didn't pan out. So I'm like, look, this is just a CNC router. I have all the parts. And then on Amazon Prime Day, a week or so ago, 2 weeks ago, I don't know, this past week and a half, 2 weeks has been like a year. Anyway, on Prime Day, I found a Z-axis. It was just a nice little mechanical Z-axis that I can strap the servo to. So that'll be pretty cool. And if I build a CNC, what I'm going to do is I'm gonna first of all, the motors are going to be ridiculously powerful for the job that they're doing. They're also servos, so they're going to be super accurate and they're going to be super fast. What I'm going to do is give them a gear ratio so that the servo motors, because they're like big outrunner motors, so they can turn very, very fast indeed. I'm going to have them turning faster by gearing it a little bit, by just doing two different size belt things on all of the axes. So this thing will be able to break your arm, but it'll also be able to do it with ease and gusto. And I think that will translate to it being able to build very tiny parts. It'll be accurate in building really, really tiny stuff. Hopefully. So I can make miniature aluminum parts for things like RC cars. I can't hear the music anymore. I don't know what's playing. That's one of the more popular parts of the whole thing. There was apparently there was the Prodigy song in this mix, which is really obnoxious because I know that they're very copyrighty on YouTube. Very copyrighty. Rightitious. And the dog is barking at stuff. It's just me and the puppy here today. But she's in for the duration of stream. She should be totally fine. I spent some time getting the schematic together too. I have an MS Paint document, just like in our other builds. We've got everything laid out. This'll serve as a de facto manual as well for when we actually start hooking this thing up to all its ins and outs, and I come back to this and look at it again. I'll at least know that I have a master document somewhere. But these are the Mutable Instruments greatest hits. Here, let me resize this window. Mutable Instruments greatest hits. And that'll allow me to build all of the different functional steps of this whole thing. I got to decide whether or not I want to have indicators on it too, kind of like Marbles has. But I had to kind of dig through Mutable Instruments stuff in order to find what the latest and greatest way of doing everything is, according to Emily, I was told to say. That's right. I remember that. But then we have to hook it up to this thing. And so we'll use one of the circuits from the ADCs and we'll see what happens. Yeah, we're still starting soon. I'm just sitting here hanging out. I have like 2 people watching, so I like to let people gather. I'm still doing the setup and stuff. You're here in time, but we haven't started yet. Not officially. I'll re-explain myself too. I know it's a little bit confusing. I know there's a blade there. I can see it. Why is that information that I need? Where's my... Oh, there we go. Boink. There's that. Okay. I hope we get to using this oscilloscope today. That means that our programming and our circuit building went well. I'm starting my first EE job on Monday. So excited. Hell yeah, brother. Congrats. Well, welcome to Excel. You just graduated at 36. That's awesome, man. Or, you know, whatever you go by. Hey, that's really cool. I'm proud of you. I hope you have a very interesting job, because what was my, you know, my first gig out of college was the IED thing. Any advice? No. I actually don't have any good advice. I really don't. I don't know what would somebody like me need to hear straight out of college. I don't know, man. Don't end up like me. There you go. There's my best advice. I don't know how to achieve that, because clearly I'm failing at it. And I've been trying so hard. All I can be is me. Let's see. I think I need to solder a couple leads down. Managed to catch myself at a blade on my bench over the weekend. Like this thing? Whoa, 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 no. Whoa, whoa. They're hard to hold on to. There's just so much circuit mess here. It's ridiculous. Try to get all these disparaging little bits of projects that I've thrown off to the side all in one big pile so that it can turbo piss me off and get me motivated to actually clean it up. I wish that one ESC project, the whatever that thing is that controls these guys, I really wish that project spilled over into RC cars, because these have the capabilities of, it's got like an STM32 on it. It has all the capabilities of being a really good RC car speed controller. And I don't want to jump down that road. I don't want to go down that whole coding project thing where I have to author an entire RC car control suite on my own. I wish it was included with this, but this is strictly on drones. These are like $14 for these, what is it? Whatever the hell this thing is called. $14 for 4 of them, right? Where's that? No, that's not the right one. Where's micro? There we go. That's a beard hair. That's a beard hair. That's a beard hair. Talon BL32, 128K. A really powerful controller. You could do a lot of cool stuff with it with drones. I wanted this to power my RC car because it's perfectly capable of hitting the current ratings of that little 3-phase motor that I have in the RC car. And then it's got like a little piece of metal on it to cool it, and it is a much smaller package. I mean, this thing has really crammed everything in there. I'm just so disappointed that it's unable to perform that task because of software limitations of availability, which makes me sound like I'm being lazy. It also doesn't have a voltage regulator on it, which is kind of annoying. You have to throw your own voltage regulator on in order to power it, and the servo and stuff like that. But that would have been super cool, because it's just small. Waiting on the company that I like in order to make their own small 3-phase controller that has sensors on it. So my low-speed stuff can be a little bit improved. I'm not sure whether or not I want to use the port expander. I've got a whole bin full of those things, so it's probably inevitable that I end up using the port expander in this module testing module. Probably inevitable because this thing has a lot of I/O, which means if we really want to, we can add I/O. I could add a keypad that goes up, down, left, right, or something. But for now, we're going to limit it to what we've planned so far, which is only a certain number of buttons. I think the look of it is a little annoying. It's a little too rigid, but we are using perforated prototyping board after all. There's maybe no getting around that. And then MIDI. MIDI is something that I didn't consider. I don't know what to do. What microscope? It's there's a scope command. Let's see, you're on Twitch? Yeah. First time chatter on Twitch. Here, check it out. I don't know how Kurokesu is doing. That area of the world is quite contentious at the moment. I think they're still doing their thing, but they've changed a lot of their product lineup. Keep in mind, though, that my setup is very specific for streaming electronics. Not everybody is looking to stream electronics. You need something like I have OBS that's showing me precisely what I'm broadcasting, and that's giving me an exact readout of what the microscope is. There are probably webcams and setups that are already doing C-mount that might be cheaper, so it might not be the right road to be barking down. I just, back in my day, converting the webcam was the way to be. There's some like scope cams that are doing like 2K and like 4K, and all you would need is that C-mount adapter, and I think SpeedyCat is the one that bought a couple of those. SpeedyCat is very good at stocking up on stuff, and he's been finding all these deals. What is the chip that I have down here? Where are you? I cannot see you. MCP 6004. Okay. So this is 6002 rather. So this is the 3-volt op amp. And I think we are doing ins and outs. We're doing I/O. So I am going to need more chips. Let me go get my chips. Ordered something similar, waiting now, but thanks a lot for the help. Yeah. Mostly, I took kind of Hail Mary shots at getting it right, and I happened to get it right. I mean, I did spend a portion of my career photographing IEDs professionally, but not much of that translated over into the setup here. A little did, but most of it was, well, I should add this to it. Maybe if I put this and this. And then I was like, oh, that's very useful because it happened to support such a long standoff. The fact that like 3 feet, 2 feet-ish standoff from the lens to the objective is perfect for my setup because I get to put everything up on a shelf. And that gives me room to work. It gives me room to wave a soldering iron around like it was a gun. Where the hell is this? Oh, there it is. It's always in the last place you look. Yep. Oh my god, I'm just getting caught on the utter sheer fucking mess that this place is. Give me this. There we go. Ha ha ha. Photographing IDs is better than taking pictures of your food and putting it on the internet. Depends on how close you get into the food, because our photographs are dog shit. They were really bad. A part of it was that nobody would listen to you, even if you knew a little bit about macro photography and how cameras work. We had to have a signature look, and the first sets of photos back when the IED analysis lab just started out were on a particular blue static mat, and so that became a signature for some reason instead of a gray static mat. The problem with the blue static mat is that the camera saw the extremely large number of blue pixels and went, oh my god, what's going on? And so it compensated so that the histogram of colors that it was getting back would be a certain look. What that did is that blew all the color of the circuit board way out of proportion. And so the photos were wildly unprofessional and had a complete fucking, like, terrible, just terrible. They were bad. And so from photos to photos, they all had terrible color correction. Improvised explosive device is what IED means. Terrible. It was terrible. It was terabad. Not a good situation. But I was just a kid out of college. Nobody listened to me back then. They'd listen to me every now and then, but actually this goes in a drawer. This thing may or may not have saved my bacon, I'm not sure. And in being able to actually measure transistors, at least this type of thing is getting cheaper and cheaper. It'd be nice if it gave me the curves, but getting HFE and HFE numbers is pretty decent, especially when you're trying to find equivalent transistors. So it's pretty cool. I found a whole article and I posted it in the Discord. I think it got buried, but it was a whole article on how to match transistors, because that seems to be something that comes up way more than I would like it to. In a shop where we're taking other people's schematics and putting them together, it's nice to have something that tells you how to match transistors, since we've gone so analog recently. Yeah, that would be a wrong assumption. Yeah. Yes, indeed. Why is this here? It's just like an enclosure. Just throw that over there. Adapters. What do I do with these? These will go in the drawer. No, actually, they should go... No, those shouldn't go there. And I do have a whole bin full of adapters, but it's RF adapters. There are some BNC things in there. Nah, maybe we'll just put it in the drawer. And I guess the module tester module won't have any, like, BNC hookups. It would be good if it did for the scope, but I don't have space on the front panel, so... It'll just have its indicator lights and stuff. We won't try to do too much with this because we need all the other functionality of it. We need it to actually function so that I can test the modules. So we can hook it up to the 303 and I can go, well, is my thing broken or is Dave's thing broken? I'll have to test it on a different module just to make sure things are good. Because what it'll do also is it'll really help me test VCOs, and then get those tuned to the ranges that they need to be. Because it'll have a pitch detector on it too. But in order to do that, we need to have our outs and our ins working. I'm wondering if it needs to be able to like do a self-test. Boy, that's a lot of work. There's a lot of work to go. We got it in us. We got that fight in us. We'll be all right. I got that dog in me. Probably should get started soon. Thinking in that direction. God, absolutely nothing happened this weekend. It was just a boring weekend. It's miserable outside because it's been so humid out there. I am not equipped to exist in this weather, and I don't think my dog is either. And then we had a scare with the dog. I don't know what happened. She could have gotten like something in contact that she's allergic to. It could be the weather. It could be this time of year messing with something. I don't know, but she got like what is this beginnings of a hot spot. So under her skin, like if you really get in there, because she's a corgi, she has like mad layers of hair, right? Very difficult to get all the way down to the skin. So I'm parting hair, and then there's like a wound, and it was just like what was a little like puck mark with a discharge. I hate to give you guys all that detail, but I mean that's what the doctor said. And so I found that, and it seems to be spreading, and so I called the vet, made an appointment, went there on Monday, and the doctor had nothing new to report. So Willa's on diabetics. She's on antibiotics, as well as a allergy kind of thing. So 2 pills, puppy's taking them. She seems to be in better spirits today. She was jumping around, but I'm worried because it's like a skin condition that she gets annually. It's like apparently about this time last year I had to take her to the emergency vet, and they gave her that funky shave. She recovered and her hair looks fine now, but she had like a lump in her butt for a little while. Now I guess I just have to wait for these to pan out and heal, and then I can brush out her hair and get it nice and smooth again. But I have to be careful when I'm petting her because there are parts that are painful. I don't know what to do. She's napping by the front door right now, so she's in her happy place. Poor little corgi. I wish we could figure out what the heck how this comes about. If she gets like a flea bite and breaks out into hives or something. I don't know. Need to talk to like an expert vet. How we doing on YouTube? Where's my YouTube page? I see the comments pop up, but I need there it is. There they are. Just the EE advice coming from YouTube. Put that over there. And then those are schematic elements, and then I've got that there. Bring this up. Click back over to here, and now I've got all my monitors and stuff. Cool. All right, you know what? I'm ready to start. We got our work cut out for us today anyway. Let me get the music out of here that YouTube isn't listening to. You guys can't hear this. It's a list of 1999 tracker music. I'm going to have to find a different playlist next time, because that one has, there's some fairly popular songs on there. It's not, I like to keep it sort of in the copyright-free realm, just in case I hit something stupid and accidentally broadcast any of the music. Music is, of course, illegal and should not be enjoyed by anyone. It's not legal, but you do have to give your money to them. Anyway, we're working on a module testing module. Now, against all better sense, I decided that in order to repair Dave's synthesizer, I wanted it to be in a little case, and while we were building a little case, why don't we make it into some kind of a testing device? And so this right here is the beginnings of what is going to become a custom module testing module. We are, of course, getting our ideas from Emily Gillette of Mutable Instruments. Now, Mutable Instruments created a module testing module, this thing, and it is a fairly old project, so it's using a lot of very old circuit elements in the whole pantheon of the invention of whatever. The point is, Amelia's moved on and made much more betterlier things, I guess, is the way that I would. But yeah, so this thing does some simple functions. Ours is going to use some parts that I have lying around, and that includes kind of an incredible screen. Now, the screen that you see here looks like it's a, 6-row character display. That's not the one we have. The screen that we have, albeit a similar enclosure, is a display. It's a dot display, but it's also a VFD. It's going to look really cool. It'll also enable us to put things like an oscilloscope on this device. Now, I don't know how far we're going to go into making an oscilloscope. If anything, I could just have fancy graphics that represent what's coming in and maybe do a couple displays. But, it's nice to be able to have the option to go down that road if I want to. And, all things considered, maybe that is where we're going to go. This could probably have a couple analog ins. I think we're going to use an RP2040, a Pico Pi, which should be able to handle things like running a screen and a DAC and an ADC. It's a fast chip. It runs at extremely high rates, and it can take a lot of code in. So we might be able to pull this off, or like a Band-Aid. But yeah, so we have 6 buttons. We have 6 I/O pins. We have an encoder. We have a DAC. We have an ADC. The ADC is, of course, going to be the built-in 3 ADC lines of the Pico Pi, or at least the 3 that we can have access to by using the whatever this thing is, this Raspberry Pi test board. These things were very cheap. Our Pi Xiao is like $10 everywhere but Seed Studio's site. So if you're gonna buy these, buy them from Seed Studio. I forgot to order them last stream, so I'm gonna have to. I'll have to double back and buy more of these. These of course power my 80. They're my VCO. I'm terrible. I'm scheming right now about redesigning the VCO, because I think it would be kind of cool if the VCO displayed to you what the waveform is, but that would involve adding an entire screen. See, one of the modules that I'm sort of building on the side is an oscilloscope module, and of course, the thing we're building today will supersede that, but this can live on the rack, and it'll just be like this narrow module that will have an O-scope, and I bought these circular screens for it. I'm going to build 2 of them, one for me and one for Julian, who doesn't have a thing that has a screen. So maybe he'll use it, maybe he'll sell it to somebody, which is kind of awkward. But either way, having a circular screen, I mean, this thing looks cool. And I was thinking, like, on the VCO, it would be kind of cute if it shows you what's going on. So when you do the mod on it, it'll show you the waveform changing. That would be really, really cool to do. I don't know. Maybe I won't do that. Maybe I'll just do the oscilloscopes. I like these projects. These are neat and fun, and they have a lot of interesting stuff involved with them, but biting off more than I can chew is something that I have to actively avoid. Anyway, so we're gonna follow the CAD here. I think I'm not gonna put MIDI on this. I think this is gonna be married to the other part of the testing module, because this will be able to measure currents. And if anything, maybe we can just have a selector where I can detach this from the rest of the power supply. But what I need to do is have an extra line come up to this that will tell it how much current is being used by the module under testing. So that'll be something that I need to build in. And while I'm doing that, I might as well put a MIDI port at the bottom of the device so that if I want to plug this, say, into like a sequencer of some kind, I can do that. But it'll have to be something that you enable and disable from like a menu. And maybe something that we just don't worry about right now and get the rest of this thing up first. See, the thing is, we're building a piece of instrumentation, and as such, it needs to be accurate, but it's very DIY. It's a very DIY kind of piece of test equipment. We need to have this thing be strong enough for our mistakes and able to do enough of the variety of tasks that we needed to in order to function properly. I don't know if we need it to be expandable much, as long as this thing is creating the types of signals that get modules to start doing stuff. And I wonder if I want these to be above the buttons. I guess we'll just do it the way I've sort of spelled it out. But this is so that you can get your dirty fingies in there and actually press stuff. the Mutable Instruments one is turned around. The plugs are above the buttons. I wonder if that's in order to like get a hand under and press the button. Oh well, anyway, we'll just stick to our guns on this one. We need to stick to our guns, otherwise I'm gonna have 10,000 designs here and not be able to get this thing together. Yeah. In that vein, I have put together a schematic, and I took the greatest hits of Mutable Instruments devices, because all of them are available online. You can look up Mutable Instruments schematics. There's several websites that have them. You can get schematics for just about every module. So first things first, I get the screen, and I make sure that the screen is able to communicate with everything. It is, and it uses 3.8 volts on its logic lines, which means the max value of the Raspberry Pi Pico from 2020 is 3.8 volts. It is exactly at the limit of what VCC Max can be, the communications line voltage. That's a little bit concerning, but it'll work. So I don't need a level shifter on that. What I do need is 5 volts for the screen, and that's going to need like probably a massive amount of 5 volts, which is annoying because everything else on this is 3.3 volts. I mean, VBus, VSys, I think VBus can be, I'm not sure. I'd have to figure that one out. I don't want to have to put, well, I can do an LM1117 on this thing, and that'll be enough current, I think, to power everybody. Although I think this does have its own 3V. So if I give 5 volts to VBus, I guess that'll power everybody. So maybe an LM1175. I'm not sure. Then we have this over here, the ADC. That's the other big module in here. So it's the screen and the ADC that I need to cater to. And the PCM 5100 we have a datasheet for. So let's take a look at what the VCC of that is. We need to make sure that and its communication lines are compatible. I think that can run, I think this can run at 3 volts, but we'll check that. And then down here, we have all of the circuit elements that are going to be required in order to get all the I/O. So here I have power supply designs and voltage reference signs, the -10 AREF down here. I think this microcontroller has a pretty reliable voltage reference. I don't think I need to bust out a like an analog voltage reference to put into ADC VREF. I'm not sure though. I'm not an expert on that. If anybody knows here or there for ADC VREF on the Pico Pi, maybe we should look something up about it. Gate inputs and outputs. So there's a clock and a gate output. So we have a very basic circuit, a 3904, just a jelly bean switching transistor, being activated through a 4.7K current limiting resistor, and that just goes out to the world. I guess it gets divided by 3.3, but that just goes out to the world. It goes out to everything out there. So it's not a clear path back to the microcontroller. It kind of could be. I don't think we're going to see like a breakdown in that direction though, because this is the strong one. If it gets super turbo negative, what would happen? I think it would still be okay. I'm not sure. I'd be more comfortable with like a 100K in there, but let's see. And then, yeah, here we have an input, the gate in. So the gate in is just, again, flipping a 3904. It's just switching a 3904. Gate signals are just pulses in and out. So we don't need anything digital there. And we have a transistor doing basically blocking stuff for us. So we keep it at 3 volts with that. This one probably needs to be at above 8 volts for that one. That's his VCC, so I guess they want it at 12. What else? That's an AREF over here. Here's a comprehensive power supply with AREF. That's got everything included. And then up here we have a control voltage input. So if we have a control voltage input going into the ADC, oh my God, Windows Update, snooze. I'm afraid of this Windows Update. We have an analog reference of -10 coming into an op-amp circuit, and that op-amp circuit is then using that -10 to shift the available voltages for control voltages all the way into the negatives, and then you scale it using the gain of the op-amp, and the op-amp flips it because it's inverting into positive. And so on the other side of that op-amp, you get 0 to 3.3 volts from a -5 to +5 volt signal. And you can change that scale by changing around well, I guess you'd probably have to change around the ratio here. So 33 to 100, roughly a third of positive to negative 5 volts, which is 10 volts. So that positive negative 10 volts is applied to negative 10, shifts it, that gets it into that range, and then we scale it down by a third because it's 3.3. So I guess this resistor here, whatever the value of this resistor is, the you know, if I put like a 10.4K, then it would be plus minus 10.4 volts. Or rather, no, that's on the output. Wait a second. It works differently than that. Hold on. The math is on it's turned on its head. Anyway, so yeah, that's how we would take external signals in to the ADC. Whether or not the ADC can interpret like waves and waveforms and stuff like that, that's, I think, going to be to like a software project. That's going to be like a, you know, wave input Arduino thing that I'll hopefully be able to find. I think there are probably plenty of circuits like that. Like look up Arduino oscilloscope or something like that, and we'll be able to get all the information out of the waves that are coming in. Probably a pretty processor intensive thing too, because it's going to be running every cycle. It's going to need to like sample very quickly in order to see stuff on there. But if we keep it in audio frequencies, it should be totally doable. And then over here, we've got what we're going to do today. I have this ADC that takes some kind of voltage in. We'll have to look that up. And some kind of a digital hookup, which is either I2S. I think I got it specifically because this is I2S, which is a sound-specific version of I2C that was specifically made for like ADC purposes. And then we have an ADC circuit from a Mutable Instruments project, and that has all of the elements of what I'm looking for. It has that stable voltage reference, and then it has, I don't know, some kind of filtering and amplifying, and then it goes into an output that scales it up to a proper voltage. Now, the thing is, we don't know what this is outputting versus whatever ADC Amelia selected. We do have the data sheets of both of those, but my eyes glaze over when we start to go through numbers like that. So what we're going to do is just build this. We'll just put this circuit down, and then I'll get this thing set up with a bunch of headers, and we can just plug this into the back of this, and we can take a look at the voltages here and adjust. We'll adjust this part of the circuit. If anything, I don't think I need this balancing here. I think just a 220 ohm resistor, or 220K here would probably be fine. Although this is 30K, because when you mix, these are the ratios of the mixture. 220 to 120 with the negative 10, and then that's supposed to become plus minus. Well, we need to be plus minus 2 volts. Because I think audio in modular racks is plus minus 2 volts. So that will need adjustment here, or here, or here, or anywhere around here, or maybe here. Fish. Okay, cool. You guys are briefed on what we're doing. I've touched my briefs on this. We need a TLO7 too. So we need 2 TLO op amps, which is not this. This is a different chip. The TLO7-2s, and then we'll hook them up to, we'll hook up the ADC to I2S. Yeah, we'll work a little bit backwards on this, but that should be fine. And then we'll measure the output on these. I guess I'll set this up so that we'll do, well, we're going to need 12 volts, and then I'm going to need to turn that into 3 volts. Oh my God, we got our work cut out for us. There's nobody in chat. Everybody's busy. Oh well, doing some good hardcore circuit work today. Have I completed my popularity arc? Am I no longer popular? I think that's what happened. When I get the POS CNC together a little bit more, we'll have some more appeal to doing like the physical part of a project where we actually get to build something cool. These have worked out pretty nicely, though. I mean, so far I've had a great time building circuits. Music. I'm not playing any music. If you're hearing music, it's not me. All right, TL072. I guess I do need tweezers to kind of pick in here. TL072. I got plenty of them. Bought them by the bushel in anticipation of doing more analog synthesizer stuff. Oh, there, it's the first thing that I picked out. There's also MCP 6004s in there, so when we test inputs, we'll be able to put that circuit together. But that input circuit is fairly easy to work with. It's fairly easy to make. I've dealt with it quite a lot. So the trick with these ICs is to do the roll. The roll's very difficult to do. You get kind of a feel for it when you do a lot of through-hole projects, and it's kind of a lost art. But it's the art of just barely rolling forward that chip so that the legs aren't like this. Coming out of the factory, these things have legs that are spread like this, and that does not help you plug it into stuff like a perforated, like a breadboard. It doesn't help you plug it in. So what I do is I grip the chip and I hold it at 90 degrees to the table, and I just roll my fingers forward, just barely. You'll feel when it starts to bend, but your goal is to bend all 4 of those pins ever so subtly into being straight up and down. It's a very subtle thing, and it looks like I'm not doing anything, but it's a very skillful and difficult thing to achieve. I guess I want to leave this area open for the screen. We'll do our stuff over here for the ADC. I want to leave myself with plenty of room. So, TL074, what's it going to need? It's going to need about 250 million resistors in order to function. Now, we need both of these op amps, and we are building this circuit here. So, let me go to, well, maybe the micro view. Oh my God, everything is so close and disgusting. And we'll just build up to one of these. So we'll just go to like this one right here. There are 2 channels on this ADC. We'll just use one of them. And we'll have to, the microcontroller code is going to be the weird part. So let's work backwards from our output here. We have a 100 ohm resistor on the output. So let's put the 100 down. I don't know if there's going to be like repeat resistors. I guess we'll just keep going through my resistor collection and dwindling it down. Let me get my through hole. Hey, Keeper, how you doing? Keeper of maps, no less. No less. I'm using like theater voice today, and it's not good because I had a hell of a night last night. I probably snored pretty bad, but I woke up a bunch. And there was like a thunderstorm that went through, and then I ran out of insulin. And now my glucose level is up in the sky, so I am in danger zone for voice health. I should probably be a little bit nicer to myself. I gotta be careful, because if I lose my voice, I don't stream. It's the whole teacher thing. Talking too much. Let's see. 100 ohms. 100 ohms. 100R. That's going to be right here. 4, 3, 2. Why are there so many increments here? There's a lot. 180. There it is. 100R. 100R. Congratulations, Keeper of Maps. You're the 4th or so comment this stream. God, it's quiet lately on Twitch. Is it just me? I think it is just me. Nobody's woken up yet. Things is quiet. All right, time to make more of these things that are going to poke me in the foot. Give me a splinter. 100 ohms is going to pin 1 of the TL072. Well, it doesn't matter. It's pin 1 or pin whatever. I guess we could just follow their lead and just do exactly what they do. So pin 1's up here, and we're trying to go to the output, which this is ground, and then I think it's ground, and then which one is the switched lead and which one is the permanent lead? I don't know. So it's one of these. I think it's the next one over. So I really want to go from here. Let's go to the output of the one that's on the same side, though. If I flip this over, that would mean that the output is in the wrong place, and it's pin 1 and pin 7. So yeah, pin 7 is that's a much better choice. So we go to there. This thing is weird. I get to choose the length, this thing, and then I can cut the leads using it as well. It is my little cheat code. You can 3D print a tool similar to this, not exactly the same, and you can just 3D print forming tools for your perforated prototyping needs. It really helps make things super duper duper neat, and I am super about having a very neat test setup. The neater your test setup is, the easier it is to troubleshoot. Troubleshooting is everything in electronics like this. God, how much insulin have I been wasting on the fact that I had to have that stupid cheap-ass barbecue. That's stuff you find in the supermarket, and every time they talk about there being some alcoholic beverage that makes up the barbecue sauce for this thing, you know all they're doing is just dumping sugar into it. I have a primal hatred for the American food palette, or what they think the American food palette is, which is lots of salt and lots of sugar. It is the worst. I think everybody buys stuff just because it's like, has to taste sugary. Horrible. So yeah, this pin would be output. And that's going to... Oh, and it doesn't seem to reach. Maybe I set up the device wrong. There. Nice and neat and organized. We are already started building a circuit. Look at how awesome we are. That was an arbitrarily chosen distance between these two elements, by the way. Yeah, British candies that are less sweet. Their beans don't have a ton of brown sugar dumped in it. And I like my beans. I actually don't like my beans, let's be honest. I don't like eating beans because there are way too many carbs in beans. It's like a joke. It's like a joke how many carbs you find in stuff. It's insane. There are resistors everywhere, and I should probably recycle some of them. If anything, I need to have a set of bins that have used resistors in them so that I can get them into like specific value bins and actually find resistors that I've used in the past. They're so cheap though. It's like $10 for a whole set of, like a whole new set of resistors. Here, let me use the tweezers. This is a little, I don't have to stretch this like this. I can actually just drop it into this one. This dude's eating beans. I need a little, wow, are those two different? What was I thinking when I built this? I have two different headers on this. What was I doing? Why did I do this? I don't have time to correct this. Why did I do? Weird. Anyway, okay, so I need to find a little jumper. I got plenty of those sitting right above me here. Although that's a little bit much. No, but it needs to go to ground, and I guess I'm going to do... Poo. I guess I'm going to do poo. I'm going to do poo. Stupid. The stupid noises I make while streaming. We need to have plus and minus power on this thing, so I guess around this, I'm going to do plus ground minus. So this goes away, and these two need to be the same. So take that one up, this one over here. Now we got to be careful with this one because this one will not have the labels that I put on the other board. I found some packing labels and I cut them up and I made little labels on the end of the board that would tell me what each of the power rails was, just to keep me from getting out of my own way, to keep me from to get myself out of my own way. There we go. I did it. I finally said something. I finally did it. Ah, come on. Damn it. Needs to be slightly longer than this. Red'll do. Red's too long. Well, I can make it do that. There we go. And I guess I'll unhook any of the other rails that we're not using, just so that I don't get confused. I guess I can power the Pico Pi with USB for now, depending on what the power requirements are for the ADC. And this might be able to power the ADC. It might have enough coming through USB and its own regulator that I can use the 3.3 volts there to go to here. We'll take a look at that in, I guess, a minute. And actually, wait, if I'm going to need this to be part of... Yeah, we're going to have to move over a little bit more. We'll have to move over quite a bit more. So let's put this as far to the right as we can, which is somewhere around here. That's actually not that far from where we were. So maybe I should drop this to a different part of the circuit and leave all the digital stuff there. That's probably where the smart money is. Let's actually lift. Let's move the Pico Pi up, and we'll have our circuit element stuff down here. It's very difficult to move this thing. It has a lot of pins. A lot of... Ow, man. But then I wanted to do the screen on these pins and have these go to the... Well, they're going to have to jump everywhere anyway, so... Oh, wow, only one row of holes on one side. Oh, jeez. All right, so that'll be okay. We'll make it work. This made me giggle, as the Brits call their candies sweets. Well, yeah, I mean, they invented them back before sugar was invented. Yeah, the placement of this is not great. Well, whatever. Let's just live with what we're doing. We'll just put it right here. It's better that we make progress over anything else. My competition is so much better at getting stuff done. I'm so sick of competing with them, but I always am. So yeah, right there. So that'll go there, which means that our ground over here, that's right here. And so I need a jumper for that, just so that we connect this thing to ground. And again, not negative, but ground. Yeah, ground's just right next to wherever we're outputting. Right there, we go to ground, bada bing. I said bada, oh boy, damaged holes. Okay, no, never mind, that worked out. That's our output there. Oh wait, no, like that, all the way on the end. There we go, perfect. That's our one output. And so now we have the feedback resistor, according to the schematic. Let's see if we can get that front and center. Huh? That looks familiar. There you go. This is going to be a resistor that gets swapped out quite a bit. Should I put a potentiometer there? I could probably put a 100K, or no, it would have to be like above that, 200K potentiometer there. What do I have available to me? Well, I could either stick something on the board that'll pop off often, or I can use my potentiometer plug-in thing that I built, just so that we had pots that can plug in and not be super turbo annoying, because the leads from these things tend to not go in enough, and then they'll just pop off. That looks cold welded. It's like a cold solder joint. So what do we have in 10K and 10K? Well, that's not 100K. It's not even 120K. It's not 200. It should be a big... Okay, so we need to actually find a big resistor pot. What did I use in the filter circuit? I'll never know where these go back in the filter circuit. That's really sad. Do I want to take apart this whole... This is like a big effort. I put a lot into this. I still don't know if it works because I don't have a source of audio to go through it. Yeah, American candies can be really, really quite sugary, and that's not good. I guess, you know, I could also put a little adjustment pot on there, but those are so annoying to work with. What's up, Angry Pizza? How goes it? We're building a circuit. We're building a circuit that'll let us test our output schematic for the device that I'm building. What I am building is a module tester module. This will allow me to give the gate signals and audio and all kinds of good stuff to the circuit and allow me to test the various elements of the circuit and get some kind of ability to tell whether or not a module is working in the first place, and also to tune it. Jelly babies? I don't know. I bought, what are they, like travel suites or whatever? Those are pretty good. But the problem is, like, you sit there and you have 1, and then you have 2, 3, and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then I'm hypoglycemic, I'm angry at everybody. Pins 6 and 7, we need to put a potentiometer between. These things are fairly useful doing that. All I need to do is bend up one of the pins so that it doesn't make contact. I can just plug it in between pins 6 and 7. Now I've done that, I can just slip this thing right here. And now we have a 25 turn, very sensitive, adjustable potentiometer. And because we're in the breadboard realm, I can pull this thing out and I can put it over somewhere else. I could put it here and short it out. No, I can put it over here and it just simply will, put it over here and test it and see what the value is. Reverse engineering that synth from the recent stream. I'm working on that in the background. That's this thing over here. I will have more of a schematic available for when we get this done. But this module testing module is a big deal. This is a big project, and it's something that I should have built a long time ago. I can't test Dave's module unless I have the equipment to test it, in which case I can get my modular synth from over there, and then I probably have some of the signals that I need. I don't have anything that'll give me a gate signal, and I don't have something where I can sustain a gate. I don't have a keyboard. I don't have a sequencer. So that's what this thing is going to be. This thing is going to be everything that I need to test any module built into a package. It's going to be basically building an oscilloscope is what we're doing. We're building a scope that has modular synthesizer features. I was considering taking that $60 signal generator thing that I bought and just taping it to a module panel, but that's not really going to work. So we're going to build something that is specifically for testing modules. Now, in my life, how often am I going to do that? I don't know. This is a lot of content. I don't think it's content that I need to be doing. I would like to be finishing projects and people go, ooh, look at you, Bother, you're doing all this cool stuff. There's so much variety on your channel. I used to get compliments like that, but unfortunately this is something that I really have to do. A similar product for testing modules is like hundreds and hundreds of dollars. So I'm going to do the work because I have all the parts. I have all this cool stuff around. So I don't know. People aren't looking to repair stuff as often as I think people think. Does the scope have any kind of function generator you could use? The little one does, but I don't know if it does it simultaneously with the scope function. But it's like a function generator is not exactly what I need. I need, and also I don't think that thing will be able to produce the voltages that I need it to. You know, modular synthesizer is its own little walled garden. Its own little walled garden of voltages. So this is not an impossible task. It is just going to be a complicated and involved task, and we know how to do those here. That's what this stream brings to the table. That's why you watch me over your favorite stupid competitor of mine who does things all cool and wears sunglasses and they're all calm and collected and blow stuff up in their shop and they laugh. They laugh a lot because they're enjoying themselves. You guys don't want that, right? You guys like my stream. OL. LOL? Why are you OL? It's not possible. That should be 200K. Is everybody plugged in? Everybody's plugged in. Hold on a second. Are you okay? No! No, I'm not okay. I bought a thing for adjusting these. It had a little hoop at the end, specifically for adjusting the... What happened to it? I don't know what happened to it. Hold on, let me look at my drawers. Can another oscilloscope help? Listen, stop trying to solve my problems. My problems are getting solved through an incredible amount of work. I bought this little thing, which is a transistor tester over anything else. I didn't have a transistor tester. I've got a very nice oscilloscope. I don't really think there's a function generator in there. There's a logic analyzer that we could really use at some point. I don't know how to use the logic analyzer yet. I'll have to look that up. Maybe someday we'll have good use for that if we reverse engineer something digital. This has a transistor tester, it has an oscilloscope, and it also has a function generator. But I don't know what voltages this thing outputs, and it's battery operated. So, you know, whatever. This isn't going to usurp the other one. Powder free. What are we talking about? People are too poor to buy new, are too poor to afford repairs. Yeah. It's not like I'm setting myself up as a repair shop. This is just a project where you can witness the process of creating a piece of test equipment. I was looking in here for... What was I looking for? Oh yeah, the adjuster. I bought a specific thing for twiddling the knobs of what do you call them? Potentiometers. But I don't see it. I don't know where it ended up. It turned out to be kind of useless, but I think I was just using it on the wrong stuff. I had a tool for this specifically, because when you adjust these, the screwdriver tends to walk off, and it like falls off to the side, and it gets really annoying. So I bought a specific adjuster for this. Why are you going down this road? You know, I didn't respond to you. So weird. What does it matter? Nothing. Put it in here? I probably... Oh, you know what? Might be in here because it would be used to adjust the probe leads. Nope, it's not. Although I do have the ones that came with the probe leads. These little, like, surface... At least the surface mount ones. If you hit them with a metal screwdriver, you can end up influencing the circuit in a way that makes it very difficult to use them for adjustment. So there's a whole family of plastic potentiometer adjustment tools like this that work really well for what they are. But then I went and looked it up, and I saw a bunch of designs for potentiometer adjusters. So I figured I'd get one and try it out. And I know I've got it somewhere. It's just nowhere that I can find it right now. Is that it? No. Nope, that's a flux pen. That's all glue. Glue. What's this over here? Oh, this is an X-Acto knife handle. Don't buy X-Acto knives. They suck. They're terrible at their job. Buy scalpels. I did indeed. I have a BS in EE. It's lived up to its title. So why am I getting OL on this? These are plugged in. I shouldn't be getting OL. I am plugged into these. Those should be making... They're definitely making contact. And then my probe plugins should be working too. Let's pop these out. Try just the leads. What's up? Hold on, wait. I lost my Twitch window. I can't see alerts. Okay, yeah, nothing out of the morning-ish. It's almost 2 p.m. here. So I should be getting a measurement. I don't know why something's not happening up here, I'm guessing. Because we need to initially tune this to 120K. It's 10 a.m. Yeah, welcome to time differences, right? So this is still pretty well established morning over there. Where's my ohms? Ah, lost them here. I mean, I guess I can peel these things open and Get them to make contact. These were decently reliable before. I wonder what happened. There we go. 142.5. Oh, would you just? Yeah, it's like slipping. That's what's going on. I need to bend some of the metal in so that it makes better contact, I suppose. Oh, I thought this was a nice, reliable thing. Turns out to not to be. Let me just crush this down. You son of a bitch! Why have you betrayed me? Why everybody betray me? Okay, hold on. We can fix this. I can fix this right quick. Let's go to this camera. Let's go to the micro. Where's my... There it is. Go to this one. Push this over. Open this up. Bend some metal. Then it'll make better contact. Ah, come on. Get this done. This is me trying to get stuff done. I end up yak shaving the whole time. Even though there's not going to be a yak with hair on it for miles. So yeah, this is just a series of bent spring pins, and I can just go in here and bend it down. So just bend that one straight down. I'm going to end up bending it back up again, but this will just give it a little bit more life before it eventually succumbs to wear and tear. So now, when I plug the giant probe pin in there, that'll make contact with it. It'll also permanently bend it, but I'm not going to lose sleep over this. You know, it's not the globe model. It's the giant T-shaped lamp hanger that spins in a clockwise motion under the dome. Metal fatigue, metal fatigue, metal fatigue. Yeah, eventually it'll break, but I mean these are all over the place. I have tons of these things, so not that big of a deal. All right, now it'll rely. It doesn't work. You son of a bitch! What is? Why must you do this to me? Why do you hate me? I think this thing just isn't poking in there far enough. Problem is, these probes are really sharp, and I don't want to mess around and poke myself. I've drawn blood with these things before. Is that it's going too far in? All right, I'm gonna poke it from the side. There. Now you can't help but make contact. Oh, you're not the offending one? Is it this one? What is... Wait a minute. There's no way it's not making contact now. No possible way. That is directly against the metal. And then these... Are these good? This was supposed to be my super reliable way to test the number of ohms in this part, and it's not working out. There are maps like that. The needle probes are good for testing like normal electronics because these are sharpened. And so if I'm testing a regular PCB and I can't find anywhere to get in on a trace, I can just stick it in there and wiggle a little bit and it'll make its way through the solder mask. It'll leave an imperceptibly small hole in the solder mask just by pushing it out of the way with the sharpness of this tip. I use these also because I can poke in on small stuff very easily. They're technically high voltage probes, so they're supposed to be able to give you the benefit of the doubt with high voltage and keep you far away from what you're testing. So you can go, eh, and then see the voltage on this thing. But they're very good for microelectronics because you can really perch them. Very sharp. I can actually poke them into soft solder and they'll get really, really good contact. So I can just use them like this. And that gives me the 142 ohms. And now I can adjust this to be 120. This is a 25 turn potentiometer. This is an instrumentation level kind of thing. Jeez, okay, gotta position myself properly. This will be good for adjusting gain. Although I'm bending the leads all over the place because it's putting up a bit of a fight. Have at you, sir. All right, 120K, give or take. Oops, sorry. All right, so that goes between pins, well, not 1 and 2. In this case, it's between 6 and 7. We flipped. There's 2 comparators inside, or 2 op amps, 2 operational amplifiers inside of this chip, and we are using the other one, so we do the opposite. BTS on a sub. You just do that to irritate me now, don't you? Thank you for the 35 months. I understand that Burn the Subs is not functioning at the moment. I would appreciate not having my chat trying to irritate me at all times. But I appreciate all the subs. They're very kind of you. All right, that goes to the input. The other side of the comparator, that'll be pin 1. Or no, in this case, it is pin 1, 2, 3, 4, 5. The reason that we count the pins like that, by the way, the reason that the pins are like 1, 2, 3, 4, and then we go 5, 6, 7, 8, is because of the evolution of the packaging that these devices sit in. Hold on, let me get a visual example over here. I don't think I have any CAN transistors on me, but we went from vacuum tubes like this, tubes that have metal sticking out of them, right? We have tubes that have metal sticking out of them here. And in order to plug everything in, I guess because lamps were round, they were round and they screw in or press in, we instead have pins on the bottom of the vacuum tube in a circular pattern for some reason. I guess that's what they decided would be easiest at the time. So when you count those, you count them anti-clockwise from a gap in the pins. That eventually translated into a little metal can transistor, and from the little metal can transistor, we translated it into a square epoxy package. And with the square epoxy package you have, and it should be familiar, you have a gap. You have a little gap marking, and then you have pins on one side and pins on the other side, but technically you have a gap. So that gap represents where your pin number 1 is going to start anti-clockwise around the circle. 1, 2, 3, 4, 5, 6, 7, 8. Gap 1, 2, 3, 4, 5, 6, 7, 8, etc. So that's it. It's just the evolution of stuff taking on the conventions of the previous generation of technology. All right, anyway. Yeah, right, Smith Clay. I can't take anything you say seriously anymore. Positive pin goes to ground. So this last one over here, we're putting to ground, not negative 12 volts. You brought this on yourself. You cried wolf. You cried wolf. I don't believe a thing you say. No, thank you. This is something that, like, I've never read about, and it's just something I was like, why are they like this? And so I don't think I looked anything up. I think I just, like, dealt with vacuum tubes and stuff. I was like, wait a minute, there's a correlation here. That's why they're doing what they're doing. Now, this design also has another adjustable on it, so I guess I'm going to put a 52K on there. But we'll try to determine what that branch's resistance is and stick with that once we're done, tuning the audio output here. This will probably give us some kind of a range or something like that. This will set the offset of the wave. So I don't know what that's going to amount to. Anyway, we need a 220 kilo ohm resistor there. And then a 30K will go from pin 1 to pin 6. Catching up at 1.5 speed. I must seem manic. Seeing your struggle with the JST connector is triggering memories from troubleshooting my mic Mic for the amp. Yeah, it's annoying. You like if you don't know how to troubleshoot, you eventually will. You will get to know how to troubleshoot. You cannot get around it. The whole entirety of the whole mindset of troubleshooting will be plowed into your brain whether you want to or not. TL072, let's just check which is the power and ground. TL072, enter. What? I didn't type that anywhere. I typed it into the chat. TL072. Actually, wait, we need this PMC datasheet in a minute. TL072, we need the right package. These TL series are kind of a workhorse when you're doing analog audio. So you need to make sure that you've got the right one. Your data sheets, because these are workhorses and it's a family of products, you have a data sheet that has like 16 different devices in it. So this right here looks like our pinout, but it's not, because this is the TL071. So we need a TL072, which has 2 op amps in it. TL072X. So now our output is, our minus is 4 and our power is pin 8. So we actually need, I really don't want to turn the circuit completely around. I guess I can. Wait a minute. If I turn this over, then it'll be pin 4. Yeah, we'll have to turn this on its head a little bit. All right, so we're turning this circuit on its head. We don't have too much stuff down yet because we're making negative here. I want to have VCC minus, pin 4, this pin on this side, so that we can get minus to minus and plus to plus. So flip it around, and then we're actually following exactly the schematic now. So we want pin 1 to go to the resistor. So I'll move that over so that pin 1 goes to the resistor, and that goes to our output, and then pins 1 and 2 will be the potentiometer. I'll flip it over so that that blank pin is sitting over here. And then pin 3 goes to ground. Or my tweezers. Oh, my voice is getting a little bad. Hopefully I can rest it on Wednesday. 1, 2, 3. I think mostly my voice is getting bad because of all the carbohydrates that I had affecting me. And snoring last night was probably a factor as well. So if I see any danger to the manifold, if there's any chance that something goes wrong with my voice, I will not be streaming on Thursday. But usually if I have a day, I can probably recover pretty well. And we're going to be working on this thing. I want to get this thing done. This is going to be like wall-to-wall project because we're DIYing this. I'm not making a circuit board for it. So I literally have all the tools I need in order to build this thing. We have absolutely everything we need except for software to build this. So if we take baby steps, if we take this one little piece of functionality at a time every stream, we will be able to get this whole thing done. Like we'll have a stream where we tune the ADC, then I can build an ADC board, put that onto the device. Then we can have one where we tune, a CV input, and then I build a little board for the CV input, and then we put that on the device, right? We do that until we're done all the hardware, and then we can do little baby step software steps. Take this piece of functionality, program like a walled-off program program a function for it, and have a little test output. Put the test output into the testes, all the test programs at the end of the program, and then put that functional block over with the functions, move on to the next piece. You do that until you're done. Basically until we're stuck with doing the UI, which is the part that scares me. Okay, what's next? Yeah, we need to finish hooking this thing up. 30K is a strange value, and I'm wondering if that's going to change based on, what do you call it? I think we're going to be using a lot of potentiometers today. At least in this circuit, because that way I don't have to keep swapping in resistors. So where are my potentiometers? Here we go. So let's do, instead of 30K and instead of 220 and 50, I'm going to put a 500 in the 220 and 50 going back to the voltage reference, which we'll build in a different area. So 500K, and I will tune that to the highest value at the moment. So I'll just bend up a lead. I mean, or I could just jumper the leads. That's true. Instead of, I think these are easier to work with if all three of the leads are in the board. So I'll set this to max value, which is going to be 270. It's a weird one. Oh, we're already at 230. 230. Get it? Have to laugh. 50. Actually, well, it should be in the middle, which would be 20 and 25, so 245. And we're at 252. That's a road around here. So I'm going to take it back to 245. Three, two, whoop. 44 and a half. Come on. This is going to be kind of difficult to adjust, actually, because unless I build what's there exactly. But I want to be able to go outside of the values that are here, because we don't have this ADC. We have a different ADC, so we might have to wander outside of the values. But that's going to make this adjustment extremely sensitive, which it doesn't really need to be. I think it goes back, like the other ones mix it with 100K. What if it's like 3.3 volts? This emote here is really, really weird. It's just this mouth under my schematic. What's happening? Yeah, maybe this is not the idea. This ain't where it's at, bother. 220 and 30. Usually, but that's for control voltages. And we're trying to get it into plus minus 2 volts. Without doing any math, I've already run into problems. Well, okay, well, let's just sub this thing in. And that'll be our connection to the reference voltage, the -10 reference, which will come in somewhere. So we'll just jumper this over to the other side of the board, where we'll then take that and go to, well, where is -10 going to be? -10 is going to be all the way up here with my voltage stuff. I think that's this one. No, this one's the LM1117, I believe. Yeah, this is my 3-volt source if I need it. This would be, yes, this is the AREF -10. So ground, -10 and -12. I did this up. These are like fancy Zener diodes, these LM4040s, but since we're doing basically what amounts to instrumentation kind of voltages, it's good to have kind of like a stable voltage supply. I don't know how this thing performs over temperature. I think it is temperature stable. So that gives us like a really, really solid reference. So let's take a really, really solid reference and let's come down here to where our op amp is. And I guess I'm just going to throw this right here and we'll hook it up to -12 and ground. So if I throw this here, of course I can't read it like this. We have one pin to ground. Our ground and our -10 are right here anyway, so... Or sorry, our ground are -12. Then -10 is in the middle and ground is on the left. Ground I need a slightly longer one for. Green fits. I'm trying to use some of these used leads. I wonder if in like a big company, if you're doing breadboarding, if you never reuse anything, you just use new stuff all the time because they got the budget for it, and it's faster, it wastes less time. I don't know. Perforated prototyping board is great. It'll never die because you can reconfigure things so easily. Maybe someday an FPGA will come along that'll be able to do it. Now, here's the trick. How am I going to do that? I need to go to -10, and I need to go to this pin over here. I guess I'm just going to plonk this thing down. Now, those first two leads are the ones that are matched to the 220K. So this one is the useless one. And to mark it, I'll just short them out. That'll just tell me what's going on. I build up circuits using salvaged components. That sounds like torture. I mean, no, not everybody can be Speedy Cat ordering 10 million new components all the time. And I salvage my fair bit as well, but it's endlessly frustrating to salvage components. I mean, that makes you an extremely skillful builder. I'll give you that. The junction of all this crap is pin 2. Pin 1 is our output, so that's here. This needs to go to several locations. It's almost better if I jump that to the other side of the board. But I'll bring this over to here, and we'll consider ourselves finally happy. Yeah, ordering from DigiKey is a total pain, especially when you don't have a big order and they charge you that $5 extra. It is nice to get the components in there with a nice like label on it and everything. Oh man, there's so many. I feel so bad about all the discarded stuff up here. All of these, not the jumpers, I mean like all the chips and stuff. A lot of stuff from Dave's synthesizers up here, and it's like, I don't know, I feel like I failed. I haven't failed yet. I'm on my way to failing. I just haven't failed yet. Once the design is good, you do all the usual stuff. It's a good way to operate. Okay, I have a jumper kit over here. I can just find the right one. So we need to go from pin 2 to that junction. So it's like a little bit smaller, but not a big jump. Oh, that's perfect. Failing is figuring it out. It's just, I'm so broken. Like, I thought it wouldn't be that bad. And we even had an answer key. We had, like, literally the engineer that designed, I guess we learned that Acid Labs is a one dude operation. So the one dude, and dude is a universal term. The one dude that builds these things has a document detailing what parts you replace in order to fix Dave's specific problem. And then I broke it. I messed it up. I screwed it up. I broke it again, and that's on me. So now I have to fix this thing. And it's just broken me. It's such a complicated device with a lot of whistles and bells. And I have stretched my ability to troubleshoot to its breaking point in order to get this circuit functional again. It's actually a much smaller jump than I thought. And it's just nothing I'm doing is working. So we're taking a break. We're doing a digital design. Digital designs are nice and easy. They don't betray you constantly. You'll figure it out eventually. I hope so. I think Dave's written his module off, but he did get a little bit of an update because Julian was shocked at the level of reverse engineering that I was putting into it. I showed Julian our whole document, our working document, and all the stuff that I've been doing. My only problem is that one circuit junction doesn't make any sense, shouldn't be in there. It doesn't make any sense. Why would there be components there? There has to be an output. Why would there be a test point? Why would there be a test point there? It doesn't make any sense. So that's one of those weird hardware things that you like never run into. I've run into stuff like that before though on circuits, and I don't remember how I got out of it. I think most of it is just getting real militant about how you're doing the reverse engineering. You go all the way down to brass tacks and you just go, all right, I'm going to just test stuff around and see what's here, what is here. Are we here? Are we unique? Are we something? And it's an Orbital song. Okay, so there's that part of the circuit. So we've got that entire upper branch. The thing we're missing is a 30K resistor going to the next set of op amps. The more you know, the more you suffer. The more you know, the more you suffer. The more you know, the more you suffer, brother. Okay, 30K. 30K, that's a unique value. Probably find one of those over here. Failing is almost all of my electronic projects. You do it for a while, you fail a lot, you get comfortable with that, You go through the process of learning how to troubleshoot. If you really hunker down with the designs, things will start to go together the first time because you've learned all of those shortfalls. You've learned where all of you've learned the breakdown. You've learned when things break down, how they break down, the things that get you into trouble, and you learn troubleshooting above all else. And knowing troubleshooting is extremely useful, whether you want to or not, you know. Okay, 30K. 39, 33. I guess we're doing 33 then. That's where all the tuning will come in handy. Now, I probably have 30K in surface mount. Are we married to 30K? 33, and then the usual value is 100. That's the usual value that goes there is 100K. Because then it mixes with the 220 or the 200K. For CV, that's for plus minus 5 volts. We'll have to do a lot of tuning there. To be honest, I should probably just put 100K there. But this is 30 and 120. We're going to have 33 and an adjustable. And then we have the balance up top. 30, 120. If it was 33 and 100... All right, let's just keep 39 and we'll see how that goes. I'll mark it down on our schematic. That is way too ambitious of a pencil size. $39K. Now this will go through an iteration because I'm actually going to, I'm actually going to build it in surface mount because I don't want to spare all the space for through hole. So this goes to from pin 2 to 7. 2, which is also over here, and then here. So actually bend them straight down. So one goes straight down, one goes straight over. And this one gets cut at a distance. Is that, well, yeah. Okay, hold on. All right. Probably should use a little bit of over, but whatever. And that goes to the same junction as pin 2. Yes. Glucometer's snapping, or my insulin pump is snapping away. Desperately trying to lower my glucose level after all that sugar. I hope I don't use up too much of my insulin. Okay, like this. Need the tweezers for this. I can't reach. Dang it. Close enough. It's never going to be perfect. Actually, I need to move it over one. Move it over by one. Give me this. Oh my god. Why is this thing so unwieldy? Probably just because of the way we're looking at it. Like I said, nice and neat. You want your circuits to be neat and tidy. Ah. Damn, this thing is fighting. I'm embarrassed. All right, that's good enough. There you go. So there's our 39 rather, that feeds back to everybody else. Now that whole area is going to need to be tuned. Yeah, just like all these stealth missions that I do. Yeah. So pins 6 and 5 are connected because this is unity gain. So I'll get a jumper for that. So 1, 2, 3, 4. Oh wait, we went to the wrong pin. Ah, I need to be 1 pin over. 1 pin over. That's why it was fitting so weird. I was rizzing my fit. There we go. Okay, so that's still connected to pin 2. Pin 2 is just taking a journey. It goes down and over, and then it's on this row and this row as well, because I put this jumper down here. So that's all well and good. We've got our pin 2 connected to pin 7. So pin 8 is here, pin 7 is here. Pin 8 connects to power, which is going to be this top rail up here. Build till short. That would be an interesting no death style run for me streaming. Is the EEs, instead of doing a a no death run where the stream ends once you die, I'll do a short run where if I short something out, the stream ends. That has the potential to end very quickly. So that's positive 12 volts. What's next? We did positive 12 volts. This has a weird design. We have a 220 picofarad capacitor. We have two 220 picofarad capacitors that are doing some measure of filtration, probably smoothing out whatever's coming out of the ADC. The thing is, with an ADC, it's supposed to be creating waves. When it creates waves, it creates sort of a lumpy sine wave because it can't smoothly transition in the way that you would think. Some ADCs anyway. So you put a little filtering caps on them, and that usually smooths things out. We might also be trying to get rid of high frequencies that are coming out of the ADC unintentionally. Who knows? But I'll put them in. 220 picofarad is an interesting value. I think I have that in the kit that I bought, because I've been buying up all these analog things. Actually, some of the ones up there might be 220s. Let's double check. These might be expressed in UF though. Yeah, these are expressed in different values. Hold on. What is this one? I should get these back into the bin. 223 J100. Now capacitor markings are weird. 223. I mean, there's no, like, you know how resistors are so clearly marked, right? Resistors are super duper clear. You're like, I know what this thing is. I've got color bands on this, although annoying, I know how color bands are expressed. Well, capacitors, there is no real convention as to how they are marked, although a lot of people have tried to make conventions for how capacitors are marked. Nobody can really agree on them. So the number 223 there is indeed a microfarad value. The question is, how are they organizing that in order to give you the value? Now capacitors are labeled pretty well much of the time, but you can still run into something where you're like, color codes, caps don't do that, or, you know, something similar to that. So, like, you looking it up helps. But yeah, the good thing about convention is the XKCD, where they make another convention. 223 capacitor. Let's look that up. 22 nanofarad. See, that's not the right. 223 would be 22 nano. 3 would be the, I guess, the number of zeros. But since capacitance values are so varied, so nanofarad, and we're looking for 220 picofarad. I like having a capacitor value chart. So 220p 0.22n, and then a very tiny value, and the code on it is 221. Oh, we were so close. A couple decades off. So 221. I have that through-hole cap kit, Let's see if we can find... No, not even close. 273, 221, 272, 222. 2.2 NF. I don't have 220p. We're looking for 221. Ah! It always works out like this, doesn't it? 223, 222. All right, that one was a 223. I should put that one back. Get these out of here. 103. Wait, 102. 102. Oh, there's 103. I see now. This is me building circuits for school, reassuring to know people with experience take as long to find the right cap. Yeah, there's a lot of like, I don't know. Hold on, 183. A lot of like comparing to like superstars at doing this stuff. And like, I don't know. I don't feel like a lot of people spend the time doing this, like actually building up the circuit and taking their time. Part of the reason that this takes me so long, it's not that I'm bad at this. I have to explain literally everything that I'm doing. Every thought in my head has to be external, and it takes me time in order to organize, you know, like what I'm going to say, how I'm going to present this, and then putting it down on the board itself. And then in addition to that, this has to come out coherent, and we have to follow a schematic. We have to, you know, I've got a lot of tasks here to be doing at the same time. I'm trying to relax. We're going to have a relaxing stream where we're doing this. But yeah, these tasks take a lot of time, and sometimes you run into things that just completely tank your productivity for the entire day. Not a lot of people know about how this stuff works. Not a lot of people do this out of college. 183, quality rolls. 183, 18 NF. All right. I'm going to try to get some of the clutter off here while I've got this thing out. And I don't know if I can go to non-polar caps, but they're called specifically for polar caps. 823, that's somewhere over here, right? 822, 823. 333. You know, we could even take longer. 223. We've had labs that try to give us the lesson of the statistical variance in components. And what that has you doing is, wait, the markings aren't stamped on there properly. That's for future me to figure out. All right, there's still more. They have you measuring each component in order to get the one that's closest in value to the one that you're supposed to be putting in. It's usually to make some kind of little astable oscillator, these stupid little oscillators that they make you build in order to fill through math problems. Exactly, yeah. Making them ultra clean is the biggest asset in troubleshooting. And then you look over and somebody else in the lab has just a bird's nest. And it works for a quarter of a second. And that's the time that the TA sees it. 223. Where the hell was that one? 222. 223. 103. Four, 7, 2. 473, 472. All right, I'm almost done this. 333. There you go. That just gets some of the clutter out of the way, so I'm not endlessly searching through caps. I feel like I'm endlessly searching through caps right now, though. Four, 7, 2. And then this one's 3, 823. That one must have just fallen out. Okay, there. Done. All right, so I don't have the cap there. I have some... Well, I don't want to search through the through holes, but I do have some polar caps. Does this have... Well, we're looking for 220 pico, not picofarad. So these are way too big. 220 pico, and that translates to what again? Where's my browser window? Hold on, I'm pulling up the browser window. 220 pico translates to 0.22 nano. So none of these will work. And the microfarad, it's 0.00022, so it's like way off. So yeah, none of those will work. And it says polar, so where the hell am I supposed to find that? I think I can probably find a... Well, I mean, I can just do it with surface mount. I definitely have the value here. 0.22U. They're non-polar. They're marked as polar on this, though. Sorry, on this. I wonder how important the polar properties of the cap are, or if that symbol is just in there by accident, because other places where there are actual polar caps, we get a plus sign. And here we've got 100 nanofarad without a plus sign. Okay, so this is just a foible of using the CAD program. They're not marked properly. So those are non-polar. So I can put in 220s from this kit here, and we can solder it down onto headers and have actual 220 pico. Did my degree in distance learning, so if I need help from my instructor, it had to be clear enough over my phone, turned into a webcam. Oh man, that is torture. That is torture. That's awful. I would hate to be the instructor in that case. Oh my God. You know, at least you made their life a little less of a hell by being neat and organized. Okay, so let's go to the microscope, and here's my little technique for putting surface mount capacitors down onto breadboard. I mean, my other question is, maybe I have these caps already soldered. I did remove a couple of caps, and they are sitting somewhere around here. Yeah, here's two. We can test these and see what they are. Oh no, these are diodes. We don't need those. We don't need those. I need capacitors, and I do have a couple. What I do is I take this header that I bought. That's the wrong thing. This female header that I bought, it's for plugging like a chip into a circuit, not for plugging another header into it. The input wire size is way too small. This thing right here. And so actually it makes some nice 0.1 inch spaced pads that I can then solder a capacitor to, a surface mount capacitor. So if I take this to capacitor measure, I measure it as a capacitor, 1 microfarad. So no, this isn't useful to me. I will put it over here though, just in case I need to test for one later. And then I can do things like, well, this is a bad example, but soldering a diode to this, I should have done it on the female header that I bought too much of. I do need to keep these components though, they're useful. They don't wear in the same way that the through-hole ones do. I don't like reusing the through-hole ones because the leads on them get all disgusting. Whereas with these, I've actually got a piece of header on it, so it doesn't wear away. It doesn't wear away the more you use it. Then I end up with big collections of these things. They're easy to test, though, if you put them into the thing and just shoot the multimeter on them. That's another diode. Well, in case we need diodes, I got them. All right, so let's make one. Pin header. And I need to find the ones that are terrible. These are the ones, they have a very small hole. Let's just double check that. Yeah, that is the one. Okay, so we'll use some of that. You buy pin header and you kind of go, oh man, that was really expensive. And then you use it as if it was the least expensive thing ever. You use them as if they are worth nothing. Like, whoops, cut that one wrong, throw out the whole row. So I need to build 2 of these. And these are 220 or 0.22 U, so that's 224. Let's double check that. Wasn't it 221? I have so many browser windows open. One. Yeah, I need 221, not 224. Oh, I don't have that in here. Cool. That is a very small value. That is not in this one. Neat. Well, maybe I have it in my other capacitors, because the big thing of capacitors has all kinds of stuff. I got to get it out of this drawer. Those are too big. Let's see here. $120 PF, 1200. That's a jump. 22 PF. We are looking for 220, which we don't have. Son of a... Why is this such a difficult capacitor to find? 2.2U, that's not even close. 0.22 nano. I don't put them in nano on this. What the... Where am I going to find them? I mean, if I take 200, or like 100 and 120, I don't have any hundreds. I only have a couple 120s. Okay, neat. And it jumps to 1200p. Yeah, just because, very, very specifically because I need it. Have I built this circuit before? I feel like I built this circuit before. Here's junk through-hole stuff from other circuits that I've built. And I've got some recovered capacitors in here. I doubt they're going to be the right thing, though. Most of these are decoupling caps. What a strange value. I don't know if I need precisely this value. You know, there's no explanation as to why the circuit is designed the way that it is. This one is going to be marked 221 if it's the right thing. I think these are all 222s. 223, yeah, they're totally wrong. These are from like a 1980s intercom system that was in the walls here that I recovered. Those are totally the wrong value, though. Completely wrong and farcical. Why everybody betray me? Okay, so, what then? I need to either get real lucky with some of the circuits around here and find something that's marked 221, or I'm not sure, maybe build a capacitor out of a couple capacitors. Those are my options. Let's see. So I've got some stuff that has big labeled caps on it. I don't think any of these are going to be that value. If they are, they're going to be tiny surface mounts. This is a sound card from 2007. I don't think that's going to be quite my tempo. There are a lot of audio-related caps on this thing, though, and it does use a DAC. So it's possible that it's doing some similar stuff, although the values are going to be a little bit different and tuned. Let's just see if we can get one at a glance, and if we don't, then I'm going to build the capacitor out of a couple of those surface mount ones. We'll just make it 240 instead of 220. I'm sure it's not going to make that much of a difference. Oh, there's all my parts for the POS CNC, which the claim to fame of the POS CNC is that it uses a point-of-sale cash register in order to have a to store the electronics for a CNC machine. That's it. That's it. That's the whole joke. So, what are you guys marked with? These are hard to read. 2 something or other. I mean, these are polars, so they're probably not the right thing. Yeah, I don't know. I don't want to remove the capacitors from this. and measure them individually. That's torture. There's an 1117. Cirrus Logic thing. I think these are pretty nice op amps in here. These are NXP things. Who knows what these circuits are like? Ah, cramp! Glucose level's falling. Woo! Let's see what it is. Do I have that on here? No, I think it's face cam, so you see me and you can see my glucose level overlaid right on top of me. There it is. See, 211 and it's falling steadily. 6 a.m. Wait a minute. This one isn't updated. Oh, no, maybe it is. Why does it say Tuesday the 23rd, 6 a.m., 12 p.m.? That's not where we should be. What's up with Night Scout? Has it not been updating? I wonder if it ran out of space. There's AAPS. There's my 211, 211. I guess just the localization is wrong. Oh no, there on the top one it says 230. Oh, I'm just looking at the wrong thing. I was looking at the wrong axis. Okay, so that is accurate. Yeah, it is correct. Yeah. I just got there. I got there. I just had to look a little harder. What am I going to do about this capacitor? This very specific value of capacitor that goes into this thing. It appears that I don't have any of them. I could try randomly testing capacitors on this thing and hope that I find it, but I think what's going to happen, like, that's too much work. I have to remove capacitors, like, in order to the bottom graph is angry. That's the, yeah, it's the time, the long graph. I guess I could just put two 220s or 120s, just two 120s against each other. This one doesn't go down to pico, right? It has two. This one has 100 pico, the 101s. How many nano was it? It was 0.22 nano. Yeah, we'll do two 100s. What's the thing you're working on? We're building a module testing module. And so in order to do that, we have a lot of little sections that we need to build up. So right now, we're working on the output, the initial output. There's 101. The output's coming from a an analog to digital converter, sorry, a digital to analog converter. Why do I always flip things in my head? What's wrong with me? 103, 102, 101. Here we go. So we're going to double these up. Oh, I've only got so many. Double these up in order to make 200 pico caps, and that'll do our whatever high frequency filtering they're supposed to be achieving here. Whatever they're supposed to be achieving, we're going to achieve through these. So we need 4 of them, and I guess I need to creatively solder them to those posts. That's not going to be easy to do. No, this isn't the huge book of circuits. The book of circuits will come back at some point. We've had terrible luck with that book of circuits. That thing has been just nasty to us. So we're not going to really give it the light of day for a little bit. This is from schematics that I've compiled from Mutable Instruments designs, because Mutable Instruments does really good stuff going from digital to analog. So put a bunch of Mutable Instruments stuff together, and if we get all of those individual components working on the RP2040, then I can find something like a oscilloscope project and maybe a UI project. And I can put those together and make a module testing module that'll help us test Dave's module, get that up and running, help me test my VCO, get that up and running, all that good stuff. So I won't really be able to do, I think maybe I'll just do capacitor standing up and just butt it up against the one next to it. That's really melting that lead, or the plastic. So get a cap. Well, actually, you know what? It'll be much cleaner if I just do individuals. Or no, caps in parallel. So I'll just layer them on top of each other. Sorry, I forgot. Caps are parallel, resistors are series. That makes this much easier. The module testing module is something that I've been avoiding because it's a very big project. But I feel motivated to do it, and I feel like if we are careful enough and we go piecemeal, and I keep this in little bites, we'll be able to swallow the whole thing. I think I'll be able to do the whole thing and make a nice thing, and then I'll put it up on GitHub. If anybody else wants to go through the absolute fucking massive pain of putting one of these things together, I mean, it is inspired by Mutable Instruments module testing module. We're basically making something with all the same functionality in it. The code is largely going to be our own, just because of the differences between having the really nice VFD display that I have. Kind of changes the game. It makes things a whole lot different. And it means that we can display things like a waveform if we need to. So I'll need to have probably some kind of Arduino oscilloscope project running in that too. And then the Arduino oscilloscope project, we of course will apply to whatever input circuits we have here, because that'll take the what do you call it? It'll be working in audio frequencies instead of whatever the oscilloscope project wanted to work in. I have to look that up. I don't even know how that section is going to work. That'll be when we do inputs. Right now we're doing the outputs, because those are the other really important thing that I'm able to do is send audio waveforms and gate signals and control signals and stuff like that out in order to influence the module under testing. We need a one-stop shop for all of our stuff. Because like if I were to do this with the modules that I have, I need to use several different things, and I wouldn't know if I'm doing it quite right. So I want to have it all in one place. There we go. 2 doubled up caps. Actually, I probably could have put the 120 on there and then the 100, and we would have had exactly the right value. These are 200s. I'm sure they're fine. I'm sure they're fine. I'm sure they're fine. I'm sure they're fine. 1, 2, 3, 4, 5. So wait, we're doing 1, 2, 3, 4, 5. So between 5 and ground. So one of these goes here. That didn't plug in right. Pin 5 and ground. What are the Unsolved Mysteries themes stuck in my head suddenly? Do 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 do. Okay, there's one, and the other one goes between pin 7 and pin 5. That's very annoying. How do I? Pin 7 is here. Can't get to either one, so I'm gonna have to just jump back and forth. It's very annoying. Pin 7 and pin 5. Well, pin 6 and 7 are connected. Oh wait, what is it? Wait, that's wrong. 5, 6, 7. Pin 7 is not the... Oh no, pin 7 also gets this. Yeah, that's right. So that goes to the other part of the circuit, but then this goes here. Pin 7 and 6 are connected together. So then, oh, so this works out perfectly. Get back in there. Hey. Don't you dare. I do have to get out of here a little bit early because I got to take care of the dog. She's very patient. She's sleeping right now. She's having a nap. got to see her friends early this morning, but I still need to take her out to do her stuff later on this afternoon. So, which is why this is a perfect stream to do this. We're taking little tiny bites of this problem. I need to go get, that's what I did. Yeah, I could have gotten the exact value if I got the caps that we have in the other bin, but I did stack two 100s on top of each other in order to make a 200 picofarad. And this is such a small value, I don't think we're going to notice if it's off by a little bit. But yeah, I got to go get insulin tomorrow, so I will not be streaming tomorrow. I was considering streaming on Wednesday. We'll see about Saturday. We'll see what's going on then. I don't think I've got anything going on. I got another life. All my friends got married or moved away. That's a little cleaner. All right, so connection to ground through the capacitor, correct. Connection to pin 7 and pin 6 and the capacitor. So 7, 6 capacitor. Other side of capacitor goes to pin 5. Pin 5 is going to have to go out through a resistor, 33K, and I think that's going to go this direction because over here we're going to put the ADC. Well, that's our -10 source there, and so maybe the ADC goes over here. Although we do have room over here for the ADC, but our microcontroller's up here. So actually up there, and then we go from the ADC. So I guess we could just build the rest of the circuit. Oh, I guess our capacitor is not going... Wait a minute! I messed up. This is not that convenient. Nothing is that convenient. You coming with me. Because this needs to go to the junction of a resistor in pin 5. So let's take this over this way. And then we can have a... I need two 33K resistors. I don't have 33. I'm going to have to make 33K. Oh boy, this is going to be annoying. This is going to be very annoying. Will those get adjusted? No, because this is a specific kind of filter that's in this area. And in that sense, maybe I need to... Okay, I need to just build this whole circuit. So I'll build this out of surface mount because I've got a much larger variety of surface mount parts. And then I can build it on one of these little prototyping boards that I've been meaning to use up. So I'll get two little prototyping boards from all the way over here. Sometimes it just balloons. All right, which one of these is it going to be? Some of these have a little field for creating surface mount designs. This one meant to like... No, it doesn't really do that. Seems like it should. Whatever. No, I'll probably just use perforated, just regular old perforated. That stuff doesn't work here. Okay, day job distraction. How dare you get distracted by what's making you money? Perforated boards. I got to get a perforated board, and I need standoffs, and I'll just make a little surface mount thing that'll have this structure on it so that I can, you know, punch it into the rest of the circuit, because it's getting a little weird with all the things that need to jump off. Speaking of that, I got this right here. Just take a cut of that. How big do I want it to be? Well, it doesn't need to. What are my ins and outs of this little board that I'm going to make? So we're going to take this stuff and put it on its own board. So we need ground, input, pin 7, pin 5. I guess. Do I really want to do this? Or do I want to make it on the breadboard because we might need to adjust that stuff? Yeah, I don't know. I mean, I guess I could build this stuff completely on like the side of the chip. but nah. No. Let's not get crazy. Let's not get crazy. Let me I guess make 2 little 33K jumpers, and that'll be that. It's just going to be more difficult to build because these are tightly packed. Wait, do I have 33K in that other kit? What about this kit? All right. $22K, $47K, $100K. Ah, come on. Doesn't have 33? 10, 22, 47. I could put a 10 and a 22 together, but that's silly. That's so stupid. All right, 33K. Let's see if I've got it in my collection in surface mount. I probably do. I have an extensive surface mount collection. I have a lot of resistors. He's a man of many resistors. 27. Okay. $33K. Yeah, I've got them in abundance. I got tons of them. I prefer surface mount. Probably should have built this as a little surface mount module, but then again, we need to figure out what some of those sliding components are going to be in order to get us our proper voltage output level from this I2S DAC. So we do need to do the breadboard thing. And then I can translate that into a much cleaner surface mount layup. And then we can make that as like a little module that'll clip onto the main device. But until then, we need to just make this work so that we can actually do some physical testing of the circuit before we commit to values. $3,302. Boy, it is quiet around here. It's just me and the dog for like the rest of the week. Usually there's stuff bonking around or something happening in the neighborhood, but it's just so miserable outside and people aren't inside here. It's just super duper quiet. Like, I don't turn on lights and stuff, so it's like dark and quiet here. Usually there's some hullabaloo going on. There it goes. Just needed to get the solder to flow in. Why is it miserable outside? It's been super humid. We have the heat breaking a little bit, but the Northeast has been an absolute shit show of humidity. We were a little bit stormy today, but other than that, it has not been good. And then when it does storm, because it's so moist out, things don't evaporate. You just get more humidity. It's like a self-perpetuating cycle. In perpetuity, it perpetuates petulantly. All right, so our ADC is coming in on one side of the 33s, and then our capacitor leaves the 33s. So if I make one of these the junction there, and the other one has to go to the other junction here, then another one goes up top. I'm trying to, hold on, let me think about what that's going to look like. So if I do this one to ground, pin 5 is here. So I already have that one to ground, right? So then another 33, and then one of these things on that same, see, I can't get this one in there. So this one goes to the junction of pins 7 and the resistor. So I need to jump here and then jump here with a jump here. At least you don't have to shovel sunshine. I guess so. I should move way up north. I'm built for the north. I'm not built for the fucking Florida-esque weather that we're getting. I'm specifically not catered to survival in Florida-esque weather. My back itches. Hold on, I'm gonna itch my back with tweezers. I think it's my glucometer site. Oh no, it's not. Weird. Maybe it's a bug that I picked up from outside. All right, so let's see here. I guess I'll step through this. So we've got the 220 to ground, and now we need a, so let me take this out of the way. We're just gonna go through piece by piece and do this because I can't seem to figure it out in my head. Not like it's a difficult circuit, it's just you get kind of caught up in making all these decisions. Pin 5, 220 ground, and then we've also got a 333 that goes to the next part of the circuit, which also goes to pin 7, which is here. But I can't get either of those out, so I'm going to bring them over. But I can't do that cleanly because we're out of space. So I'm going to have to do that. And then we've got a 220 there, which I put over somewhere over here. Oh, this one gets a 33. So that's this here. And then from this junction, I go to this. That goes to pin 7. That doesn't help me at all. That goes to, oops. Rat brain. Back here. Yeah, these are a little restrictive. I could really use leads on them. Gross Florida weather invading the rest of the U.S. Yeah, where's my polar snap or whatever the hell that thing was? What was that thing that, like, we suddenly had, like, frigid temperatures here in PA? Need one of those. All right, so that comes in from the outside. No, wait a minute. That puts this on the wrong pin. No, this is on the right pin. Because this goes, oh my God. So, my brain hurts. Why does my brain hurt? This is like not a hard circuit. This isn't hard to wire up. It's just I've got weird restrictions from these things. Hey, what's up, Pyro? How you doing? 1, 2, 3, 4, 5. Resistor ground, easy enough. Easy peasy. Resistor ground, pin 5. Pin 5 also goes to a resistor. So that this is wrong. Goes to a resistor that brings it to there, and then this can go here. Because this capacitor goes to pin 7, which is here. So I need a jumper here to here. That would be, what jumper shall I use? That is definitely not the jumper that I should use. Took a week off from work, so you're just chilling. You doing anything on that week? I don't get time off. Not anymore. Actually, I could have gone on this thing that everybody else went on, but I really just didn't feel like it. Traveling is kind of rough when you're diabetic. Boy, am I glad nobody flew from here. It's timed terribly. They would have ended up in the middle of all this mess. Okay, we can use the later one. Use this one. Took the last minute because I was sick of work. Just fuck this shit. I'm out. Hey, what up, Gonad? Well, it's a good thing you didn't travel anywhere, because you would have had a hell of a time. All the computers blew up. Our computers turned into paperweights. Who likes living in an airport? It's your new home. The terminal. All right, so there's that connection. I've had to use these my little technique of making female headers into component holders. I had to use this technique. It's kind of cursed. When I do, wait a minute. Oh God, I keep messing up the circuit. Keep messing it up. Hold on. So like the middle of the junction between those two is the one that has the capacitor that takes it all the way back. So the middle of the junction, here, not here. This is okay, but I need to get to the middle of the junction instead of the side of the junction. So basically, I am unable to do that, and I'm going to have to leapfrog to another spot, which I guess I could leapfrog backwards. Yeah. Well, this is in the way. This is where all that talk of me doing this neat just goes straight out the window. Because of these stupid stuff that I'm doing. Well, if I'm doing it over there, I might as well just spread this all the way out and do this over here. Hold on a second. Yeah, the big oopsie from CrowdStrike being the second pretty significant CrowdStrike in a week, which is odd that it happened twice. Give me this. Clown strike? No, I like calling it CrowdStrike. It happened again? No, it's the second significant CrowdStrike to happen in a week. What did they do the second time? The second time they did the first time. This is the second one. The second one involved IT. The first one involved bullets. If I do that there, hold on, let's think about this. So there's the cap to ground. Let's pull this over a little bit so we can see what's going on. Been an eventful month and we're a week into it. Yeah, I know, right? All right. Wait, you guys, that didn't scroll over for you guys? Oh, I guess I got to like put it all the way over here. Okay, that's fine. 33K, or sorry, 30K. In our case, it's a 39K. It's a slightly weird value, but all this stuff is output tuning, and we'll be able to tune the output. We're getting an ADC and we're making the output from it. So here's a 30K, and that's going into pin 7. 1, 2, 3, 4, 5, 6, 7. Pin 7 also goes to pin 6, unity gain amplifier. There's like plastic in the hole there. Pin 7 also goes to pin 6. And then it also gets a capacitor. So this is wrong. Or not. It also gets a capacitor that takes it to here. So I need to get here. I can only make a jump of 1 with this thing. It would be much more useful if this thing was 3 or a loose capacitor, but I just don't have that value. It's a very, very tiny capacitor, and for some reason I just don't have anything like them. So what we had to do is double up on caps. When you stack caps, it makes it seem like it's a double-sized gap. So they are additive to one another. So I'll put this right here and just make sure that my resistor isn't going to interfere. Which it is. that was pretty blatant. this. I can't jump over one hole because that's power. If I could do two, it could cleanly go to here, but we're not doing that. So what I need to do is I need to go from here to here, and then from here to here. Looking through my phone, photo backup. You have to pay? What is that all about? Why not just get them off of the device? You're looking through the backup. I mean, you still have the original. I need a bunch of these smaller jumpers. I don't know if I have... Yeah, they're all used. So all the smaller jumpers I can get from the jumper kit. Hopefully. I guess you can blame the people who are blindly using CloudStrike, but they assumed that the guy who messed up... What was that guy's previous job? Didn't he mess up something real bad at a previous job? They just assumed that he wouldn't mess up things in the same exact way. HEC is a paid codec, not... But why, like... Can you get your photos off of the original device? Why would you want to necessarily... Why do you need to get them off a backup? That's all I'm saying. Or wait, your phone was messed up, wasn't it? I lost the plot. I lost the plot. No, your phone wasn't messed up. It was the other person in the Discord. His phone was turbo like compromised. Okay, so now we have a capacitor that goes to the junction of the two 33Ks. The 133K goes back to pin 5, correct, with the capacitor to ground. And then the other thing that's connected to that junction goes to the other capacitor that goes to pin 7. Oh, that was tough. Basically, we had to pull that whole part of the circuit out and over here because I didn't have specific values. And since this filter, I mean, this filter's probably tuned to whatever ADC it's plugged into. We're using a different ADC. Ours might not suffer from the same stuff, and it might actually have some of that output filtration going on already. It does kind of look like it does, doesn't it? I wonder what some of that output filtration stuff is right there. Gladius88 out of nowhere, subbing with a Prime. Hey, Gladius88, thank you so much for that Prime sub. Remember, you get those Prime subs for free. Jeff Bezos is sitting there in front of a big console and a little red light is lit up, signifying that you haven't used your Prime on any streamer. It's up to you to use those. There's no reminder. So when that little light goes out and he goes, no, and his bald head gleams on a little beam of light that's coming in through the window and blinds one of his employees, you're doing that manually, right? So use it on whoever you feel like, but I appreciate them. There's no reminder. This is a little board we're going to use. We could probably look up what the schematic is on this thing. I don't know. I don't know what those two op amps are too, or whatever they are. The two little L63 whatever. We're going to plug in on the R and L outputs, which are right at the bottom of this board here. H2L or high L, no, H1, 2, 3, 4L, weird. We're gonna have to figure out how to use this thing with the RP2040, so that's gonna be kind of weird. But right now we've just set up our op amp circuit so that we can plug this into plus minus 12 volts, and it will give us an output on the headphone jack all the way over here, and then I'll be able to tune it, hopefully with only these two, be able to tune the ratio of the offset voltage level and the what is it, the line input from this filter right here. So we're going to throw this into the filter, and hopefully it's in a range that we can still use it. Yeah, not able to do a micro SD. The guy that worked in the same position at McAfee when it caused a bunch of Windows XP computers. Yeah, that's right. They expected him never to do that again, and then he did it again. Good work. So let's see, we're almost done, actually. because we're going to do 3.3 out of this. Let's look up what voltage level this thing takes. So this board is, move this over here. PCM 5100, I believe, is what we have. I don't think we have the 2 or 3 or 4. It probably signifies how many channels it has. PCM 5100. And then I need to add breakout to the search. Oh, there it is. ADC breakout. No. This is the data sheet, not the breakout board. I'm sure the data sheet has that schematic in there somewhere. Ugh. But you know, it looks like a SparkFun board. Not quite that one though. Nope. That's PCM 510. All right, get breakout out of there. Nope. 5100. PMC 5100. There's this one. That's a Hackaday. We don't run into Hackaday as often. Oh, put I2S in the search? Maybe. God, that is clunky. Nope, not the right thing. PCM 5100 I2S. There's all the results all of a sudden. Mengzong, PMD Way, eBay, TIE2E. Let's see what Amzong has in terms of, oh, that's the image. No. Visit. In terms of data. Or something we can look up? No, it's a bare bones listing. Of course. Yeah, really. Expart Electronics. I'm running on so little sleep. We had a thunderstorm roll through, and I ran out of insulin in the middle of the night. It always messes me up, no matter what. I get 10 hours of sleep. If my insulin pump wakes me up, it's I just feel terrible. I feel like I haven't slept at all. Yeah, we don't have a lot of data about this, and yet this is a very nice looking board. That's why I bought it. Ooh, pretty, yeah. These are, I don't know what the performance of this thing is like, or if it's responsible that I'm using I2S, but I am, and I think it should be pretty fun. And since it's an RP2040, it should have some pretty decent chops in order to be able to, okay, connect Mini V3 3.3 volts. I2S capable boards, any clue how to use it? This is for you. This is a manual I'm using 3 different clients. The first one is simple. Tiny and very cheap with PCM 5102 chip that'll make the sound quality much better. Maybe I should look up 5102. Acrylic DAC extension board, huh? Where do you have information about this board that you bought? God damn it. So, PCM 5102. Now we're getting it. This is probably the data sheet we had before. Nope, it's just the chip. Get out of here. Let's see. Our results are looking a little bit better. DAC sound card. Is this going to be another minimal listing? Oh yeah. Nobody's got any data about these. It's probably like a copied Adafruit product, I'm going to guess. PMD way, Element 14, Mauser. Teensy Forum. Been playing with a sub $10 PMC 5102 DAC board, and it works well using the Audio System Design Tool. That's what I was hoping we'd be able to do, is use the Audio System Design Tool and just output a frequency from it. So we can just put together like building blocks, and then it'll output a tone, and then we can get that within our voltage specifications. My ear itches a lot. I've got a little rash right here from the glasses. Yeah, just like that. This seems like a much more like clean way to do tones and audio outputs and stuff like that, is use the Teensy Design Tool instead of giant arrays of values that are output in PWM. That was the Hajiwo VCO did that. I would love to make a VCO using one of these I2S systems. Oh, and there's Paul Stoffrigan jumping in as usual. That guy is a busy person. You have to rewrite the whole library to use a 16-bit. Since the 8-weighted SNR is 112 dB, best case scenario is, how do you know these things? Unweighted spec, it's a matter of guesswork. There are no audio DACs where you truly get an analog signal with noise floor, not to mention distortion, slow, low, that more than about 19 bits. Oh, my head. Those are the best clips, tend to be quite expensive and power hungry. No audio DACs reproduce an analog signal which truly represents 24 bits of resolution. All right, whatever. I don't care. Oh God, now we're talking about the human ear. I just want to know more about this DAC. That's it. That's all I care about. I just want some specs. All right, so we can power this with 3 volts. So let's set this up for the breadboard, and we'll power it with 3 volts, and then I'll get the output to go. I'll have to solder wires onto the right and left leads, and then one of those will go into this amplifier. So I need leads. I got plenty of those. I know very little about this board, but it seems like it'll be a nice way to get audio into stuff. I guess I just want like a normal flat header. I might as well just use a normal old flat header. So this thing will plug in. I guess this part facing up, although it would maybe be better to do it like that, upside down. But then you can't see the LEDs, so we might as well just do it right side up. I want blinking lights. I like my blinky lights. So I'll plug that in flat. And when we solder it, I'll pick it up and make sure that it sits nice and flat. It's unfortunate that they did it like that, because all those now can't be accessible on a prototyping board. Once you send them away. Solder. Yes. Soldering iron on. Heat. There we go. Guess might as well be front and center for this. Oh, that's right. I forgot who you were. How's it going? Wait, what city are you in again? I'm not going to ask anything further than that, but Melbourne? Yeah, what are you doing up at 4 a.m.? Go to bed. Brisbane. Okay. Cool. Yeah, this should come together pretty quickly, but it's definitely not worth waiting up for. We've got a couple hours to go. I got to do soldering, and then we do the remainder of the hookup. I put wires on this, and then I throw it into our little filter, and then I can tune to the voltage levels that we need. We're taking baby steps on this because we're building a giant device. Something that I should probably sell. It's a module testing module. Oh, you guys found some data on it. All right, cool. I'll take a look at that in just a second. Thank you. This header is going to be completely crooked. Oh yeah, he's fine. They're traveling right now, so it's just me and the puppy dog here. Me and the puppy dog. And then she has some kind of a skin condition going on. So I had to take her to the vet yesterday. The vet had nothing to say that we hadn't heard before last year when the same thing happened. So I've just got to give her antibiotics. And other than that, she's been fine. She did Zoomies after we saw everybody this morning, so she's in good spirits. She's a corgi. She can't be unhappy. It's impossible. All right, let me open this thing up before I lose it forever. Who was that was in here? Ben Gizmo, who had data about the 303. Oh my God, I did it perfectly. I am a perfect being. That's right, I'm incapable of error. Let's see. Links. WordPress or Toddbot? MaxBug. Web radio. Oh, that's kind of cool. Yeah, these are neat little things. I like the. This would look better on a monochrome. You should get a monochrome LCD, like an LED one. I'm sorry I wasn't here earlier. Outlook. Do not apologize about not being here. So there is data in here. It is just not in my language, which is fine. We do get a schematic, which helps us know what this thing is doing. Like here, function pin. Wait, that doesn't make any sense. Oh, are these like bus lines? What's going on here? Normal latency, 44.1 kilohertz off, soft unmute, and I2S. So those are the selectors. Audio jacks are coming in there, 470 ohm, and a 2.2 ground, so there's just a little bit of filtering. Okay, so we know kind of the rest of the stuff going on here. It's like, you know, I feel like I should sell this module. It would be like $800 though, and I'd have to make PCBs for it. So this is just going to be a custom piece of instrumentation that I build for myself. And if anybody wants to follow in my footsteps, actually, the screen is $120. So if I made these into an actual product, it would be an insane product. It would be super expensive. So I'm not going to do that. We're just going to have fun building this in little bits, and it'll all come together and be cool. So the Toddbot blog, let's take a look at that one. I feel like I've been here recently. Big fan of these DAC boards, $3, 3 for $15. For playing around with audio synthesis. This video about a new SynthIO CircuitPython library. Ah, cool. They have pretty high quality audio output to at least 16 bits and separate out all the audio circuitry onto its own board with its own regulator. Oh, I see. Okay, it's got its own thing. What can I power this with? Well, it says VIN is 3.3 volts. Here's how to hook it up to an RP2040. How convenient. Correspondence CircuitPython set up using audio blah 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 dot I2S out. We're gonna use the teensy stuff. Oh, and this looks familiar. All right, good deal, good deal, good deal, good deal. So let's get this thing hooked up. I got the hookup. Oh wait, we need two more things. We need our audio output from this circuit. So we're gonna take, I think we're just gonna take RNL because ground is going to be through ground connection to everybody else. So this will be at system ground, and then we're gonna use the power from USB to power this board. USB should be powerful enough to give this power. I feel like I'm talking about like comic books, power scaling. So I have some clipped leads. I clipped some leads for myself for later. So let me find those. I think they're right here. Let me put these away because we don't need anything from these bins at the moment. Yeah, I was looking around for I2S DACs, and so apparently these things are pretty popular. Good thing that I bought them too, because it's like a decent quality. And if anything, this piece of instrumentation is going to be decent quality. It's not going to approach super high quality. I don't think I can really get there with this stuff. Hold on, I gotta put this. This thing is gold. These things, these female-to-female headphone adapters, I've got to make sure that that gets into the spot where I put stuff like that, because that's a really important adapter, especially for when Julian shows up and all of our aspirations of having a nice, easy, pluggable setup go right out that window. And then we end up having to daisy chain some kind of bullshit together. Okay, so leads. Notice that I've got plenty of these DuPont to pins. These are fairly important, actually. These are the things that I use with the scope probes, but like I said, they wear out. So, oh, you guys can't see because you're all the way over there. Yeah, so these are really nice to use for getting the probe leads onto the breadboard. But I think I have some that are just cut. They're just frayed wire ends. Maybe I turned them all into these. Yeah, that might have been what happened. So where are my other leads? Lead storage? Leads? What did I do with the box that I literally was just holding in my hand? Wait a minute. Wait a minute, I'm going crazy. I had a box. Oh, it's right under the box that I'm looking at. Sometimes you have to outsmart yourself. None of these are cut. Okay, I'll have to make cut leads. You buy these by the bushel. You can buy 10,000 of these things. Let's just take blue and white out of here. I've not run out of leads yet, but it's getting to looking... It's starting to look like I might have to order new ones soon. Okay, so I am going to cut these in the middle, just so that I have another pair in case this comes up again. One of these. Ruined forever! Oh my god. What horrors, what fresh horror is this? And then strip the ends, and we'll just solder them straight on there. They're going to be pretty weak without strain relief. But this board is going to make it into the final design, so it'll be desoldered later on. I'm not going to keep it around as a thing. Although I probably should, because this seems to be a fairly popular DAC. And I might be able to make a VCO with it, much more simple than the Hajiwo one. That Hajiwo one bugs me because it writes an entire table of variables every single cycle. Almost no matter what you're doing, it's got to rewrite that entire wavetable. But I guess it's going through the whole wavetable too, so it's using it. But it just seems so wasteful to me. Oh, there you are, Ben Gizmo. Where did you get that document about repairing the Roland? The M303 document? How did you find that? Why do you have that? Where do I get that? And can you link it again? Yeah, I've had to be on the lookout for you for a couple days now. Were you the one that found that, or did somebody else find that? I thought it was you. I made a little sampler synth using the same DAC. These TI DACs are really very good audio quality. What we're banking out of this is a module testing module. Module testing module. Because it's just about time that I need that. The M303 has frustrated me to about the end of my wit. I'm ready to throw it out of a window. I found a part of the circuit that I was reverse engineering and it doesn't lead anywhere else. And it's the primary oscillator. And I'm like, how could it not lead anywhere else? There's a freaking test point on this one resistor. And it happens to be the one resistor that burns out when you blow up the module. Was it you or was it somebody else? Somebody else linked me to the document that they use in order to replace parts when somebody plugs in the M303 wrong. L out and R out. And we're going to assume that the shared ground means that we can just route that into the rest of the circuit. This will come from, well, no, I'll just do horizontal. Well, shouldn't this be red and white? There you go. So yeah, apparently these are nice little DAC boards, which is cool. And of course, Ben Gizmo has gone completely silent after, you know, like completely silent. I get no other correspondence. Cruel, cruel world. Okay, so I'm gonna plug these into kind of their own area on this board, and then this will go like that, and then we'll run I2S. And then we can test this individually. You're trying to remember. Okay. Yeah, because was it you? I think it was. Somebody came up with a link to this thing that identified that chip as being exactly what we were using. The problem is, all I can come up with for that area of the circuit is that maybe, perhaps, I'm not using the right chip. I've got all the windows up. I can even show, for people that don't know, the M303, we've got this wonderful working document that I've spent a lot of time with putting together a circuit layout. It's basically the Germans creating their own 303, but a lot of the parts that made up the 303 are no longer available. So they had to find new stuff. Yeah, this thing is the thing that exploded. I'm still working to fix it because it still doesn't work. And actually, the module tester module is sort of a component of this, because the module tester module will enable me to do everything that I need in order to get this thing running. So I can actually know that I'm giving it all the signals that it's supposed to get. So I've been reverse engineering the circuit itself and putting it into CAD. And down here, where it's creating the oscillations, it seems like maybe I've got the wrong chip, this 3046. But then I remember that somebody, possibly Ben Gizmo, I'm not sure, jury is still out, somebody linked me to the document that whoever created this board uses in order to replace parts when somebody blows one up. And it identifies some of these chips definitively. Like, we now know that this is exactly this chip. But anyway, whatever. Regardless of that, 3046 fits extremely well in here. And putting the circuit together, I discovered that there was a part of it, and again, it's around that chip that we have sort of a very common oscillator structure looking type thing here. This is basically, you can interpret this as a diode to ground, but it feeds into the plus. We got this thing in the minus, and we got two capacitors, or two transistors facing one another. They kind of face off against each other. And then we have a 22 ohm resistor here to ground. This is the part that explodes. There's no other output though. This whole element here is isolated. I don't understand that. So it's either that I missed something, or there's something that I didn't consider. Maybe a trace blew up. I don't know. It's very, very frustrating. That's what led me down the path that has gone to us having a CAD drawing of the front panel of a module tester module with 6 in out or whatever, and 6 buttons here to test things with. It's the butterfly effect. You've missed something, it's connected. Listen, you can say that, but I've been over this circuit 20 times. That's what the highlights are. I've highlighted where all the traces go, and I still haven't figured out where the output is. So I'll have to go over it again when I'm a little bit more fresh, when I can actually think about it. But anyway, that's led to what we're doing right now, which is hooking up this DAC. Got from this MaxBug blog post, very handy from it, the schematic, PCM, blah, blah, blah. SD-based wave player. I don't need that, but... And then CircuitPython code. Okay, so we're going to run... I'm not going to run CircuitPython, though. We're going to do it from the Arduino. So what is our hookup here? It's basically I2S directly to the port on the... So is it connected to I2C? Well, let's get our VINs and stuff situated. All right, so serial clock, B clock, D in. What the heck? What does that even mean? Oh, SCK goes to ground. Okay. Just looking at the pinout that's in front of me. Let's get some jumpers here. Tweezers? Tweezers too. It's funny, I don't have those. I guess that too? It's too short. I suppose I could use green, or I could break out another jumper kit. These are not very organized in here. It's always this one distance that gets used up first. SCK to ground. And that's plus 12 right next to it, so we can't really, not really going to jump to there. Data in B clock and L clock. And then just power. Okay. Well, that's easy enough. Let's see. SCK to ground. Ground to ground, obviously. So I need another short jumper. Jumper. Where are you? I can't believe I'm out of that length of jumper. That's so annoying. So annoying. Well, I guess I can widen one of the short ones. So ground to ground. See, and then it plugs into one and not the other, and it just gets annoying. There we go. Ground to ground, and then V in needs to go to the 3-volt pin of the RP2040. We're looking at the one side of it. Let me take a look at, where did my schematic go? Did I turn that off, or did it just deactivate? It just deactivated. Oh, I have to have the window highlighted. Weird. Okay, so we're looking at this left side right here right now. Now, I will probably have to move these. Well, I don't know if these will be the pins, the ones that I've chosen already. There's no power on that side. Okay, so power's on the other side. So V-bus, V6, and then we need this pin. So 1, 2, how many is that? 5 pins down. You guys can't see it. 5 pins down. That's a big jump, but it's the only big 3-volt thing that needs to kind of hook up there. So my voice is really starting to get a little scratchy. What happened here? I'm using RP2040. This one, in fact. So it's 4 and then 3 volts is the 5th. Okay, cool. Let's bend that under the USB socket so that it's got just a nice clear path there. Blocking a lot of stuff. I could fix that if I need to, but I don't think I'll need to. Okay, so there's our 3 volts. Actually, yeah, it would be better if this is a little taller. So this bends up here. Bends over there. We're taking this piecemeal, and the first piece is going to be the DAC output. So if I have the ability to output frequencies from the DAC, then I'm going to have a much nicer time of putting this whole thing together. And if it's nice and clean, it seems like the code is going to be very clean. Let's just do GP2, 3, and 4. Unless there are specific pins for these ports. Let's take a look and see if there's specific port pins. Usually you can override it and it'll do that. But let's just check RP, or no, well, 2040. I forget what the individual board is called. The Pi Zero, Pico Pi. There we go. Pico Pi pinout. Paul. So what are they connecting it to in this blog? Serial clock, MI, and MO. Yeah, I don't think it's really going to matter where I connect it. QT102 to an adder for QT Pi or D2040 like that. And then Circuit Python. Yeah, okay. It's not really going to matter. As long as they're on GP pins. So I guess I'm going to avoid the UART 0, and we'll just go to GP 2, 3, and 4. Why not? And that's just these down here. So all I need to do is get 3 yumpers of the appropriate length. Those are too short. We're sort of in that mid-range between too short and too long. Yeah, it needs to be something like this. It's way too short. And then the only other ones. All right, fine. We'll connect it straight over. Go like that. God, these jumper kits. It doesn't, like, it goes from this to severely long. I don't have anything in the middle. It's not just me. So I guess we'll be going to like GP 10, 11, and 12 or something. 15, 14, 13, 12, 11, 10. Oh, these are labeled. Oh, no, they're not. Oh, they were. Maybe they're labeled on the other side. So, 15, 14 ground. Oh, you can see the ground. 13, 12, 11, 10. So 10, 11, 12. Straight over. Easy peasy. Just need to find the right jumper length. Too long. Too perfect. If I remember right, the LCK pin has to be 1 pin higher than the BCK on the 2040. What? LCK has to be 1 pin. Listen, why don't we just do this and we'll run into that problem when we run into that problem, and that'll be the challenge. Because that seems a little weird to me. Let's just do this and let's just see if we run into that error. We're at a nice early stage where that's not going to be a showstopper and I can just put a different jumper in. But let's not worry about weird stuff right now, because that's too weird. It's too weird. And what we're going to do is we're just going to try to see if we can see an output on this. So I need the scope on. The latest thing with my mother is that she seems to think that I say chill a lot. And whenever she tells a friend a story, she's always talking about how her son was like, chill, Mom, chill. And I don't think I ever used that word. I had to set her straight on this. I'm like, Mom, I don't talk like that. Where are you getting this from? I think she reads that Zitz comment and thinks that it's me. And I'm like, Mom, I'm like not a kid. Like, that's a comic about a mom with a kid. Like a child that's in school. It's not me. You'll always be my little bit. No. Listen. It's like you'll always be a baby until you have kids. Which I think I missed the boat on that one, so I don't think that's happening. All right, there's our output test. What up, Slam Dunk? Salam Dunk? No, Slam Dunk. Part of the way I2S works. We'll see. We'll run into those problems. Let me run into those problems. So, okay, we're going to get our I2S on the RP2040. I would like to use Paul Stoffrigan's audio library in order to run this thing. How do we do that again? Teensy Audio. Just do Teensy Audio. Teensy Audio Library. Toolkit for building streaming audio projects featuring polyphonic playback, recording, and synthesis. Now, I don't necessarily need to use this specifically for this because we're not doing anything that's that complicated. I basically just want to see an output on this thing. So maybe we don't. I don't know. We'll think about whether or not we'll do this. I need to at least get Hello World onto the RP2040, and I would like to use the regular old Arduino IDE. So I'm going to start up Arduino and my old ass IDE. Just the one that I'm used to. Father, why don't you use X? Because I don't. That's all I got for you. A new version? Nah. Okay, so board. Now I've got the Seed Zhao in here. What about the Pico Pi? Arduino AVR, Mega AVR, ATtiny, Tiny Core, Digistump, 8266, Raspberry Pi RP2040, Raspberry Pi Pico, not the W. So I've got the board installed in the board manager. I don't know any of this crap. There's all kinds of stuff here. Just a lot. It's just a lot going on. I don't know all the ins and outs of working with the Pico Pi yet. It's, you know what? I might need to look up a tutorial about how to do that. But let's see. Pico Pi. Arduino. Hello World. I mean, we did Raspberry Pi Pico, but that was for the keyboard project. So it's slightly the OS is a little bit different, right? There's a way around paying. Oh, yeah, that's from a while ago. I wonder. Try to program the RPi Pico using Arduino IDE. For that, I download the library by and the library from Arduino. Everybody that I read of says it. That's not what I'm looking for. Pico with the Arduino IDE. Let's get started. For this, you'll need, let's see. Tools, boards manager. Type Pico in the search box. Install either. Connect the micro USB. Upload the Blink code. Go to Files, Examples, Basics, Blink. File. Examples. Basics. Blink. Listen, we're not above doing this. We're not above doing this because every time you skip Blink, everything goes wrong in your toolpath, right? Don't skip Blink. Turns on an LED for 1 second and then off. Digital write, LED high. Delay, 1 billion. Digital write low, delay, 1 billion. Pin mode, LED output, right? Cool, okay. Cool. So now I need a USB cable. Luckily, I bought a thing of drawers. So I have it right here. Where is it? Wait, that's USB-C. This is where all my programmers are. There should be a USB micro, and it's gone. Is it in a different drawer? Oh, that's my spare mic. What about down here? Of course, the first thing that your drawer, conveniently full of all of the things that you need in order to perform your job, is missing the thing you need in order to perform your job. There were a couple kicking around here, so I just need to search around. Things don't go back where they should go back. It causes chaos. That's a liquid pump. That's not even a cable. It's not what I'm looking for. Where is this cable? I've got tons of them. There's you know, I just gotta jump over and get one. I probably stole it for like a keyboard or something in the weeks since we've programmed anything. Where could you be? Cable? What's this one? This one is an extender. All right, let me just go across the room and get one. There's one over here. I buy these in droves, buy them by the bushel. That's USB-C. I don't know why they didn't put USB-C on the 2040, the Pico Pi. It would have been nice. Probably would have bumped the price up though. I got a deal on USB micros. This one is exceedingly long. That's an Xbox controller cable. I need one that's like a mid to short length because I don't want it to run out of power. Like I want the data to be able to go all the way around my desk because the setup that I have has this little, it has the Valve controller weight so that I have an extra USB port, but it's totally circuitous. What's going on is I can plug into a port on the desk here, that one right there. It goes back and around to a USB hub that's right over there. It's a powered USB-C. That powered USB-C then goes all the way back over to the rack. And so the data has to go quite the distance in order to get all the way back to the computer, which isn't normally a problem, but if I put a super hyper duper long cable on here in order to program the microcontroller, sometimes it can be like, I don't know what's going on, and it'll mess up. So my understanding is that we hold the button down and plug it in. If this is a power only cable, I am going to get psycho. UF2 devices and board. Well, let's read our tutorial here. Okay, so if I plug it in without holding down the button, does it show up as a COM port? Oh, it doesn't show up as anything. Look at that. So that was actually a success. So I hold it down, plug it in, and then UF2 board, and so I can upload this. I guess it takes a little while. These tools sometimes get faster when you use them again a couple times. Because it gets all like the tool stuff together and it's like, okay, I've built that. I don't need to rebuild it if you don't touch it. So you generally don't touch a lot of those other, you know, all the weird stuff. We're not diving into folders and stuff. Flashing to D. Wrote 1 billion bytes. There's an onboard LED on this thing, right? I don't see no LED. Hit reset. Ain't no LED. Well, in spite of programming Blink, we don't know if Blink is functioning. It did say that it flashed, and it's done uploading, though. Is there a particular pin that's doing something? Let's put the scope on screen. It might just be that the LED pin is not defined. Bonk. 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 Nope. Is it getting warm? I don't think so. No, I'm not getting any heat off of that. I think there is a built-in LED. I just don't know if it's defined. Yeah, it might not be in the board profile. That seems like a big oversight because it's not like it's hard to... I think there's a pin on that. Hold on, let's look. There's a built-in LED on this, right? Yeah, there it is. That's going to that very first pin, which is doing nothing. So instead of LED built in, oh, I see. This is doing int. Oh, yeah. So if we just get rid of this and use LED built in, that's like that's just contained in everything else. So, oops, wait, give me this. Hold it down, plug it in. I am too dumb for this, but it's nice. This is step one of getting a microcontroller working, is blink. When you get it to blink, this is like the simplest thing you can do with a microcontroller. Why isn't this one updating? Up there, hold on a sec. Why did that suddenly break? Why did my tools do this to me? Hold on, I gotta get chat. I gotta chat to update on stream. Oh, the LED is blinking. There it is. Boop. So like I said, we're not above Blink. We're not better than Blink. We are just as good as Blink. That is our level of programming here. Does it actually output anywhere? I guess not. I don't see any power on the pins. Yeah, yay for things learned. What we learned something is that there's a built-in LED and that it's not pulled out to a pin. The RP2040 has tons of pins. It has all the pins it'll ever need. Oh, Gonad, I got those screens in, the circular ones. Put them over here. It's a yellow OLED circular screen. And so I'm going to make this into an oscilloscope module, which will be pretty cool. Again, this one will use an RP2040, but these will be yellow OLEDs. It'll look pretty crisp. And it'll have I'll have the front panel 3D printed, so this is flush. That'll be really cool. And then the cable can have a nice little, thing where it goes in. But it'll make a cool looking thing. You should look into those little circular... they're kind of expensive, though. That was like a $14 screen. So now we know that our toolpath works. We know how to program this thing. So I'm going to go for a new program. And I guess it's just going to be a new blank program. Something weird about the Wi-Fi or the LED on the Wi-Fi Pico. I mean, this thing seems to work just fine, and this is a regular Pico. I got the cheap one. We do not need to save the changes to Blink. Cool. So now we know how to work with this thing. So now I would like to get either the audio system tool or some other. What other things do we have? Pico, or I wonder if there's a library for the PCM 5100, but maybe. Let's see if there's a library for the PCM 5100. It's I'm kind of torn because if we do the Teensy audio path library, that'll have all kinds of crazy tools that we can use in order to create audio things. I just needed to output a frequency right now so that we can do hardware testing. We're concerned with our hardware. If I do the I2S audio system library, how married to the Teensy 3.0 or 4.0 is that? How married to the Teensy system is this? Let's take a look. Where in the hell? So many windows open right now. Draw your audio system, then export it to the Arduino. Audio included in the Teensy Arduino installer. So I already have that. And there's all that stuff. Biquad, filter. See, we have I2S. That's in. What the? Oh, good. There we are. That's in. Output I2S like that. USB, amplifier, mixer, playmem, SD wave, SD raw, Q, wavetable, drum, string. It's got all kinds of stuff, which will make creating a signal generator for testing modular synthesizers pretty nice and easy. Let's just do noise. What else does I2S need? RL, headphone, master mode, where the Teensy creates all 3 clock signals and controls all data timing. 9, 10, 11, 23. Audio from master mode I2S may be used in the sample project ADC, compatible codec. I think we just go into one of the channels like that. PCM 5102. This is it. Copy that, and let's bring it into the Arduino. Where do we put that? Hold on. Audio wire, SPI SD serial flasher. Audio synth noise white noise 1, audio synth output I2S, I2S1, and then audio connection patch cord. What in the world? Is that really the code that goes into, oh, this is for, no. I need the Arduino code. Where do I get that? Help, let me full screen. That doesn't do it. All right. I never used this before, so bear with me. There appear to be no other controls. Flexible internal signal. The tutorial is, I can't listen to it. What special thing did you, what did you touch? Is there a button on the screen that I should be hitting? Yeah, they suddenly just have code. That's weird. Oh, that's right. It's a web tool. It's over here. Nope. I might look for a library that specifically calls out the chip that we have. Because it seems like I'm not seeing, either there's something like a button that I'm missing, because the export is specifically for exporting it to the audio tool. I have to use a Pi Pico one. Oh. Is it, what is it, like a built-in? No, but you can build it here. It's just, okay, well, whatever. All right, fine. We'll use a Pico library. Now, what was the DAC that we're using? Let's see here. Oh, maybe that does go into the... I see. So yeah, that apparently does its own... It uses the patch cords and everything in the Arduino code. That's crazy. That's pretty cool. Well, I don't really want to necessarily use a Teensy on this project. I'd rather use the RP2040. I think it's faster, I think. I mean, Teensy 4 is kind of a bruiser, so maybe it isn't, but I'm using the RP2040 and a couple other things too. So PCM 5100. I guess we could look for the library in Arduino, or like that. Raspberry Pi Pico, audio line out, PCM, blah, 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 blah. That was a GitHub page. I might want to look at that one. This is essentially what we're looking at. Yep. Previous article, Max something or other. Kurt A. Tool. Per suggestion by Todd Kurt, aka ToddBot, I obtained a trio of these things, blah, blah, blah. Want to use it directly. Linked article is code for device. My adapted Pico code found here. Audio mixer demo I2S Pi. I don't really need that, but WAV file, reference, time board, audio core, audio MP3, audio mixer, audio bus IO. Damn. That's not that complicated. Huh. Audio core, perhaps. Pico Audio Wave Share. Oh, that's different. Let's go back to the original article about using this DAC with the, not necessarily this one, not the Todd.blah, the one, oh, but the one before was in Chinese or Japanese. Okay, so that's not quite right. Bring GG! Hey, bring GG! That's right, the other one's in CircuitPython. Bring GG subbing with a tier 1 for 15 months. Oh my god, hello, bother. Work is finally slowing down for the week, so I'm here to say hello, hi. My glucose level was absolutely insane, and I got terrible sleep. So my voice is awful right now. I gotta be careful that I'm not gonna damage it this stream. So PCM 5102. Raspberry Pi Pico. Let's just find a different tutorial. The 32-bit I2S DAC library. How do I get you onto my thing? See, getting started with Raspberry Pi Pico, Pico SDK, examples, SDK path, blah, 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 build as developer. Confirmed. This is probably not for me. "24-bit I2S audio." What the hell? Yeah, this is, I don't know what this one's doing. Git clone, make path, no. Let's do Arduino. And we're back to Toddot. Can this? Can the? I feel like the other audio library might be able to work with. I guess that's something for us to look up. Teensy Audio Library. There's the Teensy Audio Library, which was made for PJRC's Teensy 3 and 4. Uses Node-RED for a graphical editor, and it works just fine for playing around, making synthesizers, other things that don't require the dynamic range of a Pro Live concert rig. But as for projects, need more that's hard-coded for 16-bit, 41K, blah, 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 blah. There's a different library for Teensy 4.1. These are all Teensy's, not looking at Pi Pico. For example, I made a single driver on the Raspberry Pi Pico's programmable I/O module that does do both, based on its options for a bit of depth, channel count, frame sync. Oh my god, their application is so much different. But they are doing stuff with audio. Void DSP. Run once for each sample. How else? Loop. Serial begin. Audio begin. I2S. Audio.begin. This topic was automatically closed after 180 days. Okay, bye. Huh, why is this so difficult? Oh, this thing's still, I need to refresh that. Overlay, where is that? That would be chat. Streamlabs, overlay, chat, properties. I don't know why, it just gets weird after a little while. Okay, now, I thought I'd be able to use the Teensy thing, but I guess it's going to use stuff within the microcontroller that probably doesn't translate to other ones. Teensy Audio Pico Pi. GitHub, Arduino code embeds. CircuitPython on the Pico can do I2S. Maybe enough for the Teensy Audio build. We'll most likely use the Teensy. As far as Pimoroni module, what? If CircuitPython can do it, shifts to CSDK. Samples here. Raspberry Pi Pico Extras. There's a ring oscillator. Huh. Pico Audio. Audio output support. This is highly functional, but the API is subject to change. Pico Audio I2S. So what am I looking at here? Raspberry Pi Pico Extras. Audio PWM, Audio SPDIF, SD card, sleep, scan video, neat. Video output where every pixel scanned is scanned out every frame. VGA DPI support is highly functional and stable, but the API is subject to change. What the hell? That's crazy. Placeholder. Parallel RGB. That's wild. Okay, so audio I2S. Is it using an arbitrary frequency? Huh. That's an extras. Free audio buffer set to false. And they don't give us any information beyond that. So in the examples, maybe there is an I2S audio output. Pico Pi or RP2040 or RP2040. Siren? I don't think I want that. Boot select, fade, get cycle count, multi-core, siren, temperature, time, or happy birthday. Oh God! All right, happy birthday. Let's do it. What is it going to be? It's probably going to be PWM out of something that'll generate happy birthday instead of an actual I2S output. Include Arduino.h. Buzzer's A0. Okay, so it's a buzzer pin with note variables. That's not what we're doing. That's not what we're doing. No way. Okay. Examples again. Those are all the teensy things. Start a basic USB. I mean, I've got an RP2040 folder down here. There's only a couple things in there. Happy birthday, time, temperature, siren, multi-core. What about siren? What's siren gonna do? It's not gonna be the right one either. I should have looked up this part of the project. Simple, annoying siren. Nope. I think what I need to do is look up a library for this. That's usually how I would go about this. So if I go to the library manager, and look up the PCM 5100, maybe I'll find something. But it does seem like, where is the library manager? Is that opened yet? There it is. Downloading libraries. Oh man, if I had software lined up, I probably would have been able to like throw it in there and we could have suddenly had this whole thing working. We're trying to take baby steps here, and so there's going to be a lot of like, you know, kind of getting into our own on this and figuring out what the basics are going to be on this whole thing. These two are probably perfectly compatible. I need to look up, because Ben Gizmo had to go and throw a freaking wrench in the works. Look up the compatibility of the Teensy audio tool with just an I2S output on a different microcontroller, because I felt like it should have worked, but I guess not. Oh, what is it again? It's PCM. You want to? All right, so there are no libraries that I can use. Cool. Wait. Dabduino. With DAC, PCM 5102, and SPDIF. Compatible with 3.3 volt Arduino, Pro Duo, etc. This looks like it's kind of outdated. Let's try 5100 again and just see if that comes up with anything. Nope. Okay. All right, I got to strategize on how I'm going to be able to drive this thing easily. It looks like, I mean, this code looks like the right thing. We have includes that look correct. Defines, and this would be in Pico Extras. Pico Audio I2S. So this may be the way that we do it. I just need to get to know it and know how to output a frequency. Constant audio format, I2S setup. Can I just take this? Maybe I can just take this. This is a lot. Look at all this. What are we doing here? This is a lot. Okay, I gotta get more comfortable with I2S. The alternative here, I guess I could. What's that? I linked it above. The Pico Pi I2S support is probably what you want. What did you link? The Arduino Digital I2S library. Digital audio library. Where the RP3040 retriever device Pi does not include hardware I2S device. It's possible to use the PIO programmable IO. Oh, I remember this site. I remember this web page. I forgot about it. Digital audio input and output are supported. 8, 12, 16 board, blah, blah, blah. 6 I2S, blah, 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 API, etc. So, set data, set M clock. Sets the B clock pin of the I2S device. The LR, whatever, will be pin +1 to the limitations of the PIO state machines. Call before I2S begin. Man, you were right about that. So So this is from the Arduino Pico. Yes, I forgot about this whole thing. The Arduino Pico GitHub. Do I get an example? Don't know if I do. Desired pins, see below. I2S input creates an I2S input port. We don't need that. Bool set B clock, set data, set M clock, set bits per sample, set frequency, set sys clock, format channel. Oh my God. So PCM 5102, Raspberry Pi Pico, Arduino. And then if I look, I mean, he wasn't doing Arduino, they were programming it. This is in Python, but it does have all of the stuff here, right? Like the clock and stuff like that. Board. SPI. Where's even setting up these things? There's no values in there. There's no numbers. What pin number? Oh, board and bus IO, I see. So 9, 10, 11, 18, 17. What about settings? Steve, WAV. There's no settings in there. Oh my God. I guess, I could get the settings from wherever. Okay, that one didn't work. Oh, nobody answers. Perfect. Okay, so I guess I have to do this just from here. So we'll do create an I2S output port. Needs to be connected to the desired pins. See below and state before. So I2S output. The problem is working without an example on this. I don't know exactly what to type, so. Are they using that here? EMA size, audio PIO. They have a whole audio struct. Oh my God. Channel config, IRQ add handler. System clock frequency. Oh my God, that's too hardcore. I don't know what that is. There's got to be an easier way. Let's see how much performance I could get. ADC SD data logger. Here we go. Atomic Q. You got some fancy fast features to synchronize cores, but I'm not using them. Here's a simple non-blocking Q. Atomic, set this. SD atomic size head. No, this is, I don't understand that. Pico multi-core, atomic Q is some other thing that they made. CS pin. Okay, I think we've hit a wall. We've hit a wall where I'm unable to get code easily as I would like to. These guys are talking about some crazy shit. ADC has a design flaw? Wait, what? AVR boards, SD-FAT performance. No, none of this stuff is what I'm looking for. I mean, I could throw a Teensy 4.0 at it. We could totally change. Yeah. Yeah. I mean, I do have a Teensy 4. I've got one right here. So let's grab the Teensy 4. The thing is, can the Teensy 4 run? It probably can. The Teensy 4 is a beast. A screen and the inputs and the outputs and the I2S and all that stuff. I'm pretty sure that it can. Here's the Teensy 4. The RP2040 has a ton of I/O on the board, which is what I was excited about. Teensy 4 can run all of it. Okay, well, let's see. Pin out, change. Change places. Okay, so Teensy 4, because their audio I/O is so much easier. Let's look that up. Well, let's get this thing hooked up, and then I think I gotta run because I gotta take the doggy for a walk. She's very patient this afternoon. She does know if she really needs to go, she comes down and gets me. But I don't know if she'll have the cognizance to know that I'm home. She's probably upstairs just waiting for me to come upstairs. Because I'll come up when I'm done working and play with her. So I gotta look after my puppy. So we need regular old square headers to go into the breadboard. When I do make this device, the big testing device, I'll probably do the smaller headers. Those are really annoying to use with this breadboard because they pop out of it. But what I need are just a bunch of normal pins. Normal pins that are all the same that I can use to hook this thing up. I'll solder those down, and then I'll use their little audio library thing to try to make an output wave. And if we get an output, then we'll leave the tuning for later. The problem is going to be finding enough pins. Did I already make one of these that was breadboard compatible? I could have sworn that I did. I think I bought a bunch of Teensy 4s and then didn't do anything with them. Yeah, the 3s have pins, the 4s do not. Okay, so I need to put pins on them. Stuck rifling through, finding pins. All right, and then I need to find another one. And I'm running out of these normal pin headers. I guess I gotta order them at some point. Push comes to shove, I guess I could use the little ones, but I really don't want to. I want this thing to fit into the prototyping board and not give me any grief. I don't want it to accidentally pop out when I'm plugging in USB. As a result of my glucose level dropping, I guess my stomach cleared out. So now I'm hungry. Curse you! There we go. Found him. I guess getting to my wit's end and then cursing allowed me to find that pin header. Okay, so get that one all the way down there. Break it off. Nice and square. And then we plug it into the prototyping board because that will allow us to solder the leads and have them have just a little bit of a heat sink to draw away heat from the fragile plastic pins. This is a much, well, the footprint for this is smaller. It is a powerful microcontroller. It does not have as much outward I/O as that chip probably lets on. The RP2040 is also like $5, I think maybe 10 max, and this thing is like a $40 microcontroller platform. So there are some stark differences between the two of these. I'm not trying to pinch pennies. I just thought I'd use a relatively very powerful platform in order to run this whole setup. It would be perfectly capable of doing so. It's just that the Teensy 4 has much easier to access audio functions, which means our code simplifies just by an incredible amount. The audio analysis as well as output functions that this thing is capable of are quite nice using this sort of programmer that we were looking at online, the Teensy audio stuff. Teensy can do over 600 megahertz. It can kick the Pico's butt. Really? Well, I guess we'll use it then. I guess we'll use it. This is a big deal piece of equipment anyway, so this thing has to do all these functions in order to help me test other modules. Look at that pretty microcontroller. All right, so let's get this thing soldered, and then we can throw a little bit of code onto it. Move this over here. I haven't sat up this entire stream. You guys make sure to move your legs. Don't sit as long as I have today. I'm in a stool, so I'm in a slightly different position. You don't want to get those blood clots. Those make your brain work no good no more. All right, so getting this thing soldered, we just go pin to pin. And since this is already plugged into the breadboard, everything will be nice and aligned. This is our ASMR dirty breadboard soldering stream. Visual ASMR. God, so I bought these sausages, right? It's always the good start of a story. So I bought these sausages, and they're filled with cheese. They're cheese bratwurst. Don't knock it till you try it. They're pretty good. The only problem is I grilled them up real nice, and then my first bite into one, the cheese completely liquefies, and it becomes this incredibly hot napalm. And so the whole front of my tongue was just completely obliterated with my first bite into these sausages. I'm so mad. I was like, make sure to let them cool down. Make sure to let them cool down. Make sure to let them cool down. And then I took one bite, and it was like, poosh. It was freaking Vietnam right on the tip of my tongue. And so now I have a painful tongue tip. It sucks. All the taste buds are fried. So maybe I don't know whether or not they're tasty. All my taste buds have been obliterated. But it's like that kind of burn where it isn't like painful, it just feels weird. I guess it is a little bit painful. It just feels very weird. It's like I got like sandpaper on the front of my tongue. Oh, come on, solder. What are you doing? What's the board? This is a Teensy 4.0. It's going to allow us to do some of these audio things that we wanted to do. Put together a module testing module. It is the perfect application for a Teensy because Teensy projects are crazy and you can build a whole synthesizer with one. We're going to use it to make something that helps us test other modules. We are essentially making a synthesizer with a pretty big UI on it. What is the lock stamp? Paul Stoffrigan makes these, and he is a one-dude operation, I think. It might be a couple people, I'm not sure. But the one dude makes these and sells them, and so that lock, I would assume, means that this microcontroller has been given the Teensy bootloader and then locked. You can buy the chips with the bootloader on it, but I don't think he's giving away the bootloader. But the Teensy uses these, what is that, NXP? Microcontrollers that are brutal. They're so powerful. They're a really great development platform because you get all of the clock cycles. The thing is an absolute legend in terms of speed, and that way you can get whatever project you're trying to get done in it without running into any limitations. And then you can scale things back for production. IMXR 1062, fast and software software support is amazing. I don't like using those little weird microcontroller features that you would need software support for. I don't like doing that. If you do that, it makes your code much less scalable from chip to chip to chip. And so, like, for instance, in ornamentations and crimes, they used those weird features that the NXP microcontroller is capable of leveraging, and it bit them in the ass because Paul Stoffergen was unable to get the microcontrollers that he wanted to get, and so he end-of-lifed the Teensy 3.2 because NXP was like, nah, we're not going to make them anymore. Fuck you. And so without making the price skyrocket, he just moved on to the next iteration of hardware. That left ornamentations and crimes with a bunch of code in hand that will not work on the Teensy 4. Now, there are teams that are working on updating that, and I think they've probably made significant progress by now. I think it's probably available on the Teensy 4. It's just the fact that that entire situation came up at all is terrible. Remember a keyboard project for converting an old Apple Macintosh keyboard to USB? Yeah, oh yeah, the old school Teensy has been used for a lot of cool stuff. A lot of cool stuff. All right, so how are we doing audio on the Teensy 4? We don't need the Raspberry Pi stuff anymore. Jeez, that's not what I'm looking for. Well, that looked like a cool, cool project. Jesus Christ. That's a fast processor. Okay. Pins. The pins. Jeez, I need just like an easy tutorial. You can still get the Teensy 3.2. No? At least for a little while you weren't able to. He'll sell it to you if you're building just a singular project with it, but you have to contact him on a forum in order to get him to, or send an email. I could really use just like a tutorial. PCM 5102 DAC and TC4. Am I missing something? Audio DAC and volume. No output. TC4 audio board input from an electric guitar. Is there an example of... I can show you the connections I used in the mini synth if you want. Sure, that'll help jumpstart me to where I need to be. Because it would be Teensy Audio. So the audio library, which I believe we already have installed and everything. So all I need to do is audio design tool, and we have noise going into I2S, just so I can see something coming out. I mean, I could probably find like a sine wave too, if I really wanted to. Yeah, waveform. I can do that, but I'm just going to do noise into the one channel of the I2S. Jump share. Oh my God! Oh, these are cool notes. All right, so what am I looking at here? 15, 14, 13, and then 12 for ground. Sounds good to me. All right, so let's get that wired up. Fired up. So we're looking at 15, 14. I really don't want to flip this thing over because I want the output to be over here. And is that 3 volt out? Let's just, well, before I do that, we'll hook up the... Yeah, I just need those couple of pins. Just those couple connections. So those are going to look like slightly longer wires. They're going to have to be kind of an ugly loop of wires. Oh yeah, but I don't have any jumpers that are that... Well, whatever. Okay, so... pin 15 to LR clock, whatever the hell that means. Welcome to the chat room. Oh, thank you. What's up, Nano? L clock. To 15. Then D in output 1A. So D in, you have it going to out 1A, but I guess you have it labeled as D in. That's pin 14. Oh, I see. That's the PCM. I'm looking at the wrong end. I'm looking at the wrong end. Hold on a second. Does it matter what pins I'm connecting to on the TNC? So D clock, LR clock, 20 and 21. Well, it's a good thing we have long wires here. So L clock, LR, left right clock is really what it is. So that goes to pin 20. And then D in goes to STDET 3.3, LR. These are nowhere around each other. I'm just learning how to do this, so things are going to be a little bit crazy, and I'm kind of following this like the letter of the law. 7, 20, and 21. 7 is out 1A. That goes to... does that go to D in? And then BCK goes to 21. I see. So this one goes to 21. We're following Ben Gizmo's hookup, just so that we know we got something that works, and then I can get fancy with it after that. Who painted a lock on the processor? They stamped it to say that they've locked it and put a bootloader on it. That's how you keep... Why can't you guys understand that that's just the way that you organize things when you're uploading a lot of code to a lot of devices? You want to put a marking on it so that you know you've messed with it. That way you can have a ton of them out on a desk and not, you know, totally screw up your whole operation by sneezing. People sneeze. It happens. We're disgusting. We're disgusting creatures. That's not... See, it's either too long or too short. There's just nothing in between. All right, so pin 7 here. And it's just going to have to go through a big loopity-loop like this. That's horrible. There's got to be a better length. It would reach, but it would be really disgusting. And there's nothing beyond this. It doesn't, there's no mid-length. What about that? Wait a minute, red might be it. Red ain't it. Red ain't it. It might do. That'll do. It'll have to do. All right, so we're plugged into the same pins as Ben Gizmo is. I don't know what that means in terms of ports and stuff. Like it's not like I put the settings into the tool, is it? It's just I2S1. And let's get a teensy pin out here. Oh, here we go. Wait a minute. 22, 23, and 9. I guess we'll just change it to be Ben Gizmo's pins. But wait, does that stay in the comments? Where is it even? Minimal code, I was able to output a decent sine wave. board, Teensy, VCC, ground, LR, clock, DIN, VCK. That's in the commented out code. Include audio.h, sine wave, I2S1. Maybe because that's I2S1. Which I2S are we? These pins also work? Okay, well, hold on. I need to pin out from a Teensy 4. Computer, Teensy 4.0, pin out. Right away. Okay, visit that. Take a look at this. Down we go. Open to tab. Open in a new tab. PWM, LR, blah, blah, blah. Okay, so LR clock 2, B clock 2, into B and L1. So we're currently set up to use 1. And in the tool, if I can ever find the page again, we're doing I2S1. So we're currently set up on I2S1. So we got that. It's literally the page that I'm on. It's right here. Or no, it was somewhere. Anyway, this is all we're doing. We're just outputting noise. So we export, and then I just copy this, and then click OK, and now I can put that into... I should probably keep setup and loop, huh? And that's it? What do I do in setup and loop? Nothing? Nothing? Oh God, let's get some of this stuff out of the way. I guess I lost my page that had, oh no, yeah, I closed it initially. Darn it. Halfway down? All right. Oh, I closed it. Hold on, I'll get it back. I haven't worked with this yet, so I don't know what I'm doing. Thank you for your patience. Those are audio samples, supported hardware, library development, processor usage, etc. I should probably look through the tutorial. That'll probably help. The link above has the pins. Teensy3 audio. Well, I don't care about the pins anymore. I already figured that one out. I think I have some of these boards sitting around somewhere. The Teensy audio things. I might have one. Maybe not. Maybe I didn't get one of those. But this is not important. I just need example code to show me how this works. We might have the proper code in there now. Now that I've put that in there, I think it's just going to output. Well, let's try. Let's just see what happens. That one. Where'd this go? I dragged it off to the side. Tools. Oh, well. Yeah, tools board. Teensy 4.1. Or sorry, 4.0. I'm thinking 4.1. Yeah, it's jarring to me to not have anything anywhere in the code. Like, we're not setting up the pins, we're not doing anything. It's all in the background. So if I plug this in, oh, I didn't hook up power. I need to hook up power to the other board too. So let me do that real quick. So Teensy 4 pin out. I'm gonna have to, you ruined my MS Paint drawing. I'm gonna have to find the Teensy and put that in there. I'm just as happy to use it though, because I love that processor. It just makes my whole design. Well, I'm using a $120 screen, so I guess I can't really say that it makes my design too expensive. I can't say that. 3 pins in. Oh, and I need to do ground as well. So let me just get that done. So if we're going to, I have a ground over here. Do that to this ground. So now our grounds are shared. So we have a shared voltage reference. The TT library is very good at handling it all for you in the background. Yeah, it's really kind of quite nice that way, and that lowers the burden of coding on me quite significantly. Over to VN. It was practically in the same spot. That really helped. Having both platforms have the VN at just about the same area. So now I plug this thing in. Both of them light up with power. Actually, this one wasn't lighting up before, so. And then we go to Arduino, and I do tools, TC4, serial 600, optimize, sure, do whatever, port, what the hell, HID, vid, PID, raw HID, raw, TC4, upload. Oh, we need to make a project on this. This thing hates my network drive, though. Oh, that's right. It doesn't let me... Actually, will this work? I think this is not connected. It's just the Windows share seems to think it still exists. Yeah, it's not connected. Windows just, for some reason, thinks it exists. Project on the Z drive, though. Problem is, it doesn't let me save. I need to work with the permissions a little bit and make that actually work. I'll try to save it here. Ready? Yeah, you don't have permission. I do. It's just going to be a dick. So module test. It's so annoying. I gotta fix that file server. I don't know what's going on. I think I need to like blow away the permissions on maybe on this computer, because it's been it logs in automatically and does all that stuff. But it should have permission to read and write on the file server. I used to have it set up perfectly. I was able to try, like when I'd reboot this computer, it would be locked out of the drive until I logged in. I think something weird is going on with the credentials though, and it gets confused. Wow, this is a lot of compiling. A lot of compiling. All right, so once this thing is good to go, with the scope on, we should see on one of the channels, that's just ground noise. Hold on, let me get ground connected here. Okay. Well, we're not seeing noise. Oh, it's still doing its thing. It's still actually compiling. It's taking its sweet time to compile, because it has to do this from nothing. I have not used any of the TC4s yet. Looks like it's getting done compiling now. And then it uploads, reboots okay, and we're back. So let's just see, nothing there. Nothing there. There's no noise here. No noise, let's check the pins. We're definitely I2S'ing. Nothing going on there. Did I get that pin wrong? Which one is that? That one is BCK or whatever. Sound compiles like a few seconds. It's never compiled a TC4 before, so it has a huge amount of work to do to get all the different weird things together. Just microcontroller stuff. Okay, so we're close. We're really, really close. There is data coming out of this. DIN is coming from which pin? Hold on, let's double check. Double check our pins. We're looking at L clock, B clock, and then out 1A goes to DIN. So, but the problem is there's no data on that line. I don't see anything happening here. It is dead. Oh, that was ground. Hold on. Put ground back into ground. Are our grounds connected properly? Yes. Ground, ground, ground. And then our power goes around to power and we get power. Seems to be okay. So we do D and whoa, I changed scenes to a weird one. That's still weird. What am I doing up here? There we go. Sorry. I'm all over the place. Where's our scope? Look at how much room we have to work. So currently we're plugged into pin 7. Pin 7 is out 1A. And there's nothing going on there. Out 1A goes to our D in. L clock goes up and around to pin 20, which pin Twentington is LR clock 1. B clock, whatever the heck that is pin Twentington. So Twentington goes up and around and to the right, so that's connected correctly. So we have no data. There's no data running around. Is there some kind of a trigger that I need to be giving in order to make it output data? I didn't see anything. I said just, hey, put noise out on that line. Unless it... Is there an alternative? Out 1D is pin 6. Nothing. M clock 1, SPDIF, SPDIF, SDA, SCL. Out 2 is pin 2. Nothing. Let's look at all of them. Do a little down the lane observation. It seems like I2S is working. It's doing stuff. We're not doing the output that we thought that we would be doing. Let's take a look at that's the wrong one. Oh no, that's the right one. Blah, 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 blah. Take a look at the tool. God, that's hard to... Noise 1, nothing else to it. Port, out 0, white noise. Amplitude, level. Set the output peak level from 0 to 1. The default is off. Noise is generated only after setting to a non-zero level. Setting the amplitude to 0 causes this object to stop using CPU time to generate random numbers. So we need to set amplitude on this. What do we do? Do we do like, is it like noise 1 dot amplitude? That? Declare audio memory? Is it like cap like that, audio? Or do I need to assign it to memory 10? That. Audio memory 10, amplitude 1. Is there, wait a minute, there's probably an example, isn't there? Teensy threads, Teensy SD 1315. Oh, that's actually going to be really important because that's for the screens. Touch screen, blah, 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 blah. Graphics, Arduino. There's probably an example in here somewhere that would show me all that other nonsense about how to use those audio things. I'll have to look them up. This is going to massively simplify this piece of equipment, though. Let's give this a shot and just see if we don't have something. Let's upload it and see what it does. See if that actually gets us to output stuff. Wait, why isn't chat on here? What the oh, because where did my... I have to have this tab active, otherwise it dies. You guys haven't seen that Big Gizmo's been helping me through this, in spite of my being a little too stubborn to work with. It's been a fully interactive chat day. Oh, my poor puppy. My poor puppy. She's been waiting for 4 hours and 30 minutes. This is cruel. Sometimes I'll take her out for a walk in the middle of the stream, but she doesn't come downstairs anymore. Yeah, see how much faster that compiled? All right. So now is the question. Noise? Oh, we have noise on one channel only. Hey, that was sort of easy. I could have used an example from the start. I guess that would have helped out a little bit. Now that I know kind of how these audio plugins work, I can do all kinds of stuff using one of these little DAC boards that are like, these are like $10 and it's a pretty powerful DAC. How hot is this thing getting? Okay, so the Teensy gets kind of warm. Noise, 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 noise. You can add one line and make it appear on both channels. I can, but what I can also do is take it over into the circuit that we built earlier. Oh, we can have a nice rounded stream where everything happens perfectly and we do just right. See, here our voltage level, actually that looks pretty good, to be honest. That looks like it's somewhere around plus minus 2 volts. Let me move in on that a little bit. Well, 2 to 4. That's actually kind of an appropriate amount of audio there. We might not need to do anything in order to get this over to. Wait, that's not line level at all. That's kind of weird. We're on X1 mode for the thing too. This is an expensive scope. As far as scopes go, it is actually pretty cheap for what you get from it. I bought this as a very large numbered birthday gift. This is my super duper, you're a fucking old man now birthday gift to myself. And the thing is, actually, you know what? We can just move these over. I think it was totally worth it for the work that we do around here. For the work that we do around here, we do a lot of reverse engineering, signal stuff. We do all kinds of crazy things with electronics, and to have a scope that I'm able to use a web page, it's an intranet web page, to pull up on stream and give us the ability to look all around. Wait a minute, I'm on ground. What? Jeez, that was weird. I was looking at ground. Here's the data that we were missing. So that's what that stuff is. And then here's the actual signal through a proper ground. That is a strong signal. I can't believe that this goes all the way up to 3.3 volts. Yeah, I didn't have these values, so I had to do a little mod. The problem when you do this, though, is that you can only jump one location, so it makes your circuit get bent out of shape. So, power supply. So. Power supply over here. And then we need our plus and minus 12 volts to run the rest of the circuit. Oh man, I'm getting all these viewers now, but I need to take my doggy for a walk. Oh, I need plus minus ground. I need the whole suite. Hold on. The whole gang. I need the whole gang. All those jumpers are still sitting on the power cables that I moved out of the way at the beginning of stream. Plus, ground, minus, and I'll hook up channel 2 on 6 volt scale, the same scale as the input. So the blue overlay is going to be our output. I'll plug that into the phone cord, the headphone cord, like that. So that's direct output. Now, when we get the module tester module working, doing stuff like this is going to be so much easier. It'll just be jumpers everywhere. Viewers? Who has viewers? What are you talking about? So let's see. Plus 12 volts is going to be connected to this one. Minus 12 volts is going to be connected to this one. And then ground is connected to this one. So I have minus, just like triple checking, to make sure that I get this right so I don't blow anything up. Minus ground plus. So that's going to go through the mutable instruments circuit that Amelia, I believe I refer to her as she, I'm not sure, connects to her DAC. I think it's she, her, isn't it? And then I have adjustments on the outset. Let's see if this works first try. It appears to work first try, but boy howdy is it lowering the amplitude of the signal. And let's just pause that. Enhance, 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 enhance. The cool part is that when it comes down to it, when you open this intranet webpage, you can actually adjust stuff on the fly. You can poke the screen and adjust things. I don't know if that's my input. I'm not sure. I don't actually know. Our scale is like millivolts. Look at how clean that signal is, though. There's a little bit of wobbliness coming out of it, but... Do you need to buffer the audio output through an op-amp or to use just as is? The board has a headphone plug on it, so I assume that they're doing whatever buffering. What's up, Whiskey? This reminds me of Radio Shack breadboard kits. We've come a long way since then. PCM 5102 output is higher than line level, 2.1 volts. Wait a sec, that means that I could just use it. This is like automatically set up for Eurorack then. I could use maybe like a buffer, but not really. Maybe we have, I think I have a Radio Shack breadboard somewhere. I used to have one. I don't know what happened to it. It was the most bullshit breadboard I had. It was like bad. It had huge borders around the edges and it was just kind of badly made. Actually, the metal was probably better than the metal inside of these ones now. These modern breadboards actually go bad a lot faster than the old ones because they use cheap metal because everybody's got to make margins somewhere, right? The line has to go up, so we get to deal with shittier and shittier stuff. So what's going on right here is I've been doing a lot of modular synthesizer stuff, like building modules and fixing modules. I ran into kind of an issue with this one in the reverse engineering process, and it pissed me off. So what I did naturally is have a stream where I don't have to think about nothing. And so we put together a plan for a modular synthesizer testing module. Now, Mutable Instruments makes an amazing module. She's really good at what she does. I copied her design, basically. I took a bunch of different elements of the design as well as the actual concept of a module testing module. And we're kind of trying to build something that's basically this. So this is sort of the overview, but I started digging around for parts and I found that I have a very nice screen module indeed. This is a vacuum fluorescent display module that does characters, and it's got 4 quadrants. Well, if you use the tools from Noritake, you can have 4 quadrants of functionality, which is great because this thing I think primarily does 4 functions. We'll have to organize that at a later date. Right now, we're doing these sort of lower level stuff, getting the microcontroller to do individual functions. Why is that? Why are you warm? Why is this warm? Oh, this is the 10-volt reference source. This gets a little warm. This 10-volt reference source might not even be necessary in this location since this is going plus minus 2 volts, which is modular synthesizer levels, which is actually kind of fucking amazing. It means that I can buy these things and make modules out of them directly. That's crazy. The audio output is fine as it is, but it has about 470 output resistance built into the PCB. But anyway, the plan is that we're gonna modularly, we're gonna go through this in baby steps. And so the first baby step is getting the digital output to actually do something. It turns out, though, that the output from the DAC is much different than I thought it would be. It's much smaller. I can adjust it with these, but I don't know if I really need to. I could actually take the direct output and put it out to the module that's being tested, which is amazing. See what adjusting this does. One of these should have a pretty big effect on it. Should be like an offset. It's not really doing anything. It's just such a small output level. Man, that's crazy. Yeah, this really isn't doing anything. I wonder if it's actually working. What if I cut off... well, if I cut off the input, obviously, something's going to happen. Well, we're not monitoring it anymore, is what's happening. Where'd the noise go? Noise, noise, noise. There's the noise again. There's that. If I take out the 10-volt reference, yeah, see, nothing happens. Try to blow it up. Without the reference... no, something does happen, but I don't know if it's desired. Yeah, you can barely see it kind of cinch in a little bit. Make it do a sine wave? All right. What are the pots even doing? That's the thing, is like, I'm looking at noise running through the system. It's hard to see what's going on, but it should be shifting and growing and shrinking. Supposedly, I mean, according to the way the op amp is, I'm just setting up the biases weird. Maybe I need to put it into a generic op amp circuit that has the adjustments on it. Let's get like just a sine wave in there. Pink, noise, DC, tone sweep, PWM, waveform. Hit it up with waveform. Put that into our other ear. And then we'll have to figure out how to use it. We can export that, and basically it's just going to be another small branch. I guess I have to get the whole thing. I have to get the whole thing. So we'll get the whole thing there, and we'll put that in up here. There's a second connection. And now I can declare the waveform over here. So begin waveform 1, begin the waveform has. I can hook up like a potentiometer and stuff like that and make it so that I can change the frequency and stuff. But for right now, we'll just waveform 1 begin, and then begin level, frequency, and waveform. So level is that amplitude? Yeah. 0 to turn the signal off. So I guess 1, full amplitude. We're not going to give it an offset. Phase angle, no. Pulse width, arbitrary waveform. So frequency, what is the C note? What's the brown note? 261.63. What is it in? Frequency 440 is A. We'll do 261.63. I don't know if it's going to be in hertz, though. Yeah, that's not a thing. And waveform. Well, is there a list of the waveform sine? Waveform underscore sine. Is that right, or is that not? Supported waveform, waveform underscore sine. Sample hold. Oh, they put an E on there. There it is. They put the E on. They're not math majors. Output a waveform and set the frequency, amplitude, or set the amplitude and frequency. Frequency, change the frequency. It doesn't give me a unit. What's the unit? I don't know if that's going to directly translate into a frequency. Well, let's give it a shot. I mean, that'll just begin it. So upload that. This is fun. You can do all kinds of weird stuff. Why is chat still not showing up? You know, the social stream blades are working just fine. There's that. Have there been YouTube comments that I've completely missed? Just a Madam U saying, hey, hi Madam U, sorry I didn't catch you earlier. It's in Hertz, so it should by all means. So if I take this one out and I bring this one in, look at that sine wave, and our filter is doing horrible things to it. Look at how clean that is. Look how clean that is. And it's plus minus 2 volts. So this is what an audio output on the synthesizer is anyway. I should probably put a buffer amp in there. Yeah, something's wrong with the filter. Something is very clearly not healthy, and it is begging for the sweet release of death. Kill me. Please kill me. At least you know the sine is getting all the way through, albeit chopped. Some horrible stuff. That's why I use this DAC. Yeah, it's completely amazing. I was considering using this specifically for I2S. Oh, here we go. It's just clipping. There we go. Into an FPGA so that I could do some pretty advanced stuff. But I haven't gotten there yet, and this just happened to be in all my stuff. But this is like, if you're doing stuff with modular synthesizers, this PCM5102 test board, it's like 10, 14 bucks. And it appears as though I get 2 channels that I can use directly out. I mean, honestly, I'm just going to do unity buffers just so that you don't blow up the DAC. Something's flipped. Shouldn't that be wave match, or is it supposed to be inverted and offset? Listen, nobody's perfect. I think what this is supposed to do is take a very tiny signal, I think, and boost it up. And I don't know what the filter, I think, is smoothing it a little bit, but it looks like it's amplifying noise because it's going so low. I think this is to get around a more herky-jerky DAC. But like, look at how smooth this DAC is. I'm not seeing any shelves on this thing. There are no shelves. Maybe a little tiny bit. So I don't think I need the mutable instrument stuff, which is a data point. This is what it's going through right here. So this is supposed to filter out, like, probably the waveform is probably like that, and this just filters it to make it smooth. I can't draw it as easily, so this is not needed. And then this was probably boosting it because it went from 30 to 120. That's probably boosting it, and then you balance it on the number line. So this is probably just needed just a unity gain. Wait. Buffer. Just like a little doggy. He's a buffer. What? PCM 5102 EVMU, $199? What are you, well, hold on, what are you smoking? We had the page open with Amazon a minute ago. $12 for 3. Like, I don't know what you're looking up, but $12 for 3. It looks like my chat's working again, too. It's built into the DAC the PCB is on. That is such nice news for me. I should have gotten the 3-pack, because holy shit, that, like, I need to make just a generic, and I could probably do this with perforated prototyping board, but I could just make a generic Teensy 4 audio library module that I can just use the Teensy 4 audio. This is amazing. all of my plans shall come to fruition through this. This is amazing. So much easier. So that significantly lowers the amount of work that we need to do in order to produce the rest of this module. And I probably could have made this stream into 5 minutes, but here we are. We're at closing time, a normal closing time, and we have a successful circuit, except, you know, the filter is a little bit fuck, but who cares? This thing pretty much works. That's where my schematic came from. I had the same idea. Pretty crazy, huh? Okay, well, I learned something new. Yeah, this thing, it's rare that we get such a success at the end of the day. Manami reference, that's the original TI evaluation board. Yeah, when you buy something like that from the company that makes it, it is messed up how expensive that they think they can make stuff. Messed up. The, you know, $300-$500 evaluation boards, and then you need to buy another couple $100 of stuff in order to get everything working properly. It's when you go into the DIY stuff where somebody's just made a breakout board that you get all the cool stuff that's affordable. The Teensy stuff is annoying in how well it works. It's kind of incredible. Paul Stoffrigan is like my hero. He's really awesome. I've emailed him before about getting LED stuff, fast LED stuff working way back in the day, and he was responsive and friendly and all that stuff. Very, very cool. I should pick some of these up now. It's like $11 for 3 of them. It's kind of amazing. And you can literally just do a perforated prototyping board with this and this on it and a couple knobs, and that's an entire modular synth module. All right, for something working. Input is going to be the next animal that we have to slay. Solid Electronics has subbed with Prime for 22 months. Solid Electronics, thank you so much. And yes, hooray for something working. I could make some guitar stomp boxes. I don't know what the output from guitar is supposed to be. This is at positive. This is like a 2 volt, positive and negative 2 volt, which could be problematic. Like if you plug headphones into that. I guess it's okay for, is that okay for headphones? Oh, that's exactly what Ben Gizmo is doing. Standalone sample synth with Teensy and PCM 5102. That makes the output part of this so much easier, and we can do some of the scope functions using the node style setup. And then we can have it output particular frequencies. What do we measure this frequency as? How accurate are we for our Hertz value? So if I do, let's get channel 2 out of there because it's distracting. Look at how clean that is. Oh my God. Okay, anyway. Let's do a little bit of math. Actually, no. What are we doing? We're doing measure. See, right now what I'm doing is I'm operating this with the buttons on the scope, but you guys don't have to see that. Even though I did get the dark mode scope, so we're not blasting our eyes out. It's nice to have the dark mode scope, but you guys get to see the exact outputs from everything. So what I'm doing is I'm measuring frick. Measuring frick. I can't do a good falsetto. That's a horizontal thing. Frick. And then that's it. 261 point, and that's varying a little bit. Pulling more of the wave, pulling less of the wave. I want a chart of that. Can I get a chart of that frequency? Oh, here we go. There it is. That's all the specs that I wanted. .44 to 88. 261.63 is the average, which is the number that we put in. We put in 261.63 into our code. And it's doing the best it can, and it's varying around it a little bit on the decimals, but it's doing pretty well. Oops, wrong one. That's one. I don't know if zooming in on a half wave. Ah, my Stream Deck. Why did I kick it? Oh, the violence. The violence. God, I hate this little stand for this thing. I should 3D print some other kind of stand. Actually, I should get the XL in here because that would be much better. Why is there a math enabled? Oh, because it's measuring, I see. What's our average? 262.47. Yeah, it's not able to measure it as well if you don't give it enough. I feel like that's as far in as I can get it. It's pretty accurate. Every time I come back to the stream, I want to buy this scope. It's an expensive scope. The model below it is probably just as good at this kind of stuff, although I'm not totally sure about that. Don't take my word on that one. This was purchased with my money, so when I complain about it, I have real complaints. I had to replace the fan with the like blue fan that's like kind of the same size, but it doesn't move as much air, so this thing gets a lot hotter now. So it probably won't last as long, although I think it'll probably outlast me. It's about time to get that thing out that makes the squiggly lines. We're making the squiggly lines. We've made the squig. This thing is making our squiggles for us, and it's doing a really good job. It's actually doing an amazing job at that. So this is definitely going to be the audio engine for this, the rest of this thing. So yeah, the zooming way in on this waveform is very clean. Let's take it up to the maximum that this scope can handle, which should be a lot because this is the, oh no, not fine. This is the better model of the Rigol scope. And let's get time into the center here. Oh yes. Oh yes, that's something else. I don't see any granularity on this fucking thing. Yeah, outputting to an intranet web page. It's just a local web page that you can control via clicking. I'm not doing that right now. I'm using the actual scope to do the controls. But like, this is also a touchscreen scope. The big thing that I'd say that this thing doesn't do is boot up quickly. When you first turn it on, you think it's broken because it doesn't turn on. I'm good with my cheap Tektronix oscilloscope. Maybe if I stream, this would be great to have. That's the thing. Is like I have the Cadillac because it makes me look cool. Like it makes me look cool and do cool stuff. But I need that web interface, that quick web interface, so that I can show you guys signals that change dynamically on stream. If we're reverse engineering something like we did with that digital protocol, I can have a waveform up and say, oh, there's a bit of data right there, and you guys can follow along. The PCM 5102 is currently getting 16-bit audio, but it can even work up to 24 and 32-bit if you want even more resolution. And it's not supported, right, by the audio stuff. Those resolutions are like, that's out of control. That's like movie audio. I don't need anything like that. All right, so success. I think my dog is going to explode if she doesn't get outside soon. I don't hear her barking. Oh, I got to get my blood glucose off of here. At least my glucose level is normal. Finally. I gotta go make her dinner and all that stuff. She's been neglected this afternoon. We had a success. Luckily, apparently the Teensy 4 is super duper easy. The Raspberry Pi Pico can handle this thing. It's just a little bit more code, and people have been working on the PJRC, whatever it is, the Teensy audio stuff for a while, to the degree where people in chat know exactly what I'm doing before I'm doing it. And it's so simple. It's just like Node-RED putting stuff together, and you're, oh, there's my audio engine. So I highly recommend, even though the Teensy 4 is like $30, it's not a cheap microcontroller platform. It's affordable though. It's fast as hell. and the audio stuff is dead simple. So that's the way we're going to go. It should have enough memory on it. It should have enough speed, certainly, and it should have enough speed. I guess that's everything to run my screen. And then we need to take a look at audio input. So we need to do audio input. All of the knobs and stuff are easy peasy. I know how to do that. The other part is running the screen. So there's two parts left that we need to do physical breadboarding of, and that's input and the screen. Affordable to me. How much is the Teensy 4? I'm not talking about my scope. My scope is not affordable to you. It could be. It's not affordable for a hobbyist. It was $1,000, so I think it was 9 something. Don't buy them anywhere else but PJRC's website, because it's like the studio. It's like the Seed Studio Zhao. If you buy that anywhere else, it's way too expensive. I think I got mine through Amazon. There, get $23. Come on, 23 is affordable. You just put the avocado toast down. You stupid millennial. Just pull yourself up by the bootstraps, which is a phrase that was meant to signify something that was comically impossible to do. Just do that. Just go through your couch cushions until you get $30. It is expensive these days for a microcontroller platform, but I think the amount of time that I saved with this thing makes it worth it. This is a brutally fast processor. Hopefully it has a long life ahead of it, but doing this audio stuff has been just monstrous. And I've only barely brushed the tip of the iceberg on what this thing is capable of doing. Oh yeah, wrong end of the planet. That's tough. I don't know what to do about that. If you have Amazon anywhere around you, they do sell on Amazon, but getting it shipped from the Murica land might be a little bit difficult. I know there's difficulty in doing that. I can't help you beyond that. Love Teensy. My joystick wouldn't be close without it. Yeah, it and the support. The Teensy joystick stuff is like dead simple as well. It's amazing. It's like you choose, like, you can have the weirdest setup possible. You could have Flatulent Gonad's whole setup, and you could route all of those functions, all those buttons, all of it into one of these things, or a couple port expanders in this thing, and making the joystick out of it would be a series of, like, just a drop down, and then you assign stuff by saying, you know, joystick button 6 is this. It's amazing. Oh man. So Mr. Anderson says Teensy 4 is the equivalent of $80 US on Amazon from Sweden. That's terrible. You actually have a non-scammy seller, not Amazon, who carries Teensy. That's good, because this stuff, like, as an American, $23 and tack on a little bit of shipping from there is absolutely worth an entire development platform that can handle any project you throw at it. So check out Berrybase in Sweden. I can't recommend that stuff to you guys. Yeah, you guys will have to. And by the way, this is actually one of. And by the way, Jack, no, this is actually one of the main advantages of the Discord, is that you guys can talk about this kind of stuff. Like, you know, where do I get this in Sweden? I've seen a lot of discussions about that on the Discord. So if you really want to, like, you know, try to procure some of the stuff that I have been working with, and you're in some advanced weirdo country, you can try to find support on my Discord. Okay, I gotta go. My corgi has been sitting upstairs like a very patient girl, and the whole neighborhood is probably out there taunting her, especially the birds. So she will get treats. Do not fret. She will get treats. The end card is, of course, as usual, broken, but it does have links in it for the people on Twitch. Jeez. Yeah, so there's all my info. You guys can follow if you feel like. Thank you for all the subs. I will be back on Tuesday. I got to do errands tomorrow, otherwise I'm going to die. So I have to do errands tomorrow, and then on Thursday, sorry, next stream is Thursday. I'm so discombobulated right now. Next stream is Thursday. Tomorrow I got to do errands. I will be on Discord. I don't know if I'm going to get anything done on this, But so far, this has been very easy. We'll throw like a unity gain amplifier on it. We'll work on inputs on Thursday, and we'll try to figure out if we can get one piece of this working. Maybe we can have it measure tone or something like that. We'll see what twist we can do, because this Node Red style audio stuff looks like it's like amazing. It's super easy. It's like cheating. It's like cheating. I shouldn't be allowed to do it, but I'll definitely take advantage of that. So I'll see you guys on Thursday.